Good morning. Hello. You all look so pretty today and smart. Thank you. Smart, particularly. Did everyone have fun last night? You play some games, do some karaoke? I heard there was some Les Mis at karaoke last night. There's some talented musical artists in this audience. No? That's cool. So I just want to remind you all that we have a code of conduct. Remember, we talked about that a little yesterday. If you see any violations of the code of conduct, just reach out to one of the purple-shirted friends of React Conf and just let them know. There's also a Slack channel. Also, remember to be inclusive. If you see anyone sitting by themselves, be like, hey, friend, let's talk a little about React or about food. Yeah. Also, my friend here, Susan, I'm going to give her away to a member of the audience. She is very high-end. Her jaw moves when your jaw moves if you've got a reasonable size head, which I do not. So I'm going to give her away to whoever claps the loudest for every single speaker that comes up on stage today and whoever laughs at every single one of my jokes. Yeah, and the NSA is here with cameras everywhere, so I'm spying and I know what you're doing, so don't try to hide from me. I'll just keep her backstage or whatever. Just let me know anything you need. We also have gender-inclusive bathrooms on the 3rd floor. If you're having trouble finding those, just reach out to any of us and we will help you. But mostly, I'm super stoked to be here today. I'm super stoked that y'all came back, and we're going to have an awesome time. The first speaker today is Brian Vaughn. He's incredible. He's super nice to everyone on Twitter, including me, which is weird. Not everyone is. And his favorite food is sushi, which I think is weird to eat at breakfast, but he's just been backstage eating piles of sushi. So he has stinky breath. No, he doesn't. Okay, everyone give it up for Brian. Let's get started.
Hey everybody, hope you're all having a good time at React Conf so far. Yeah! Great. My name's Brian Vaughn, and I'm on the React core team at Facebook. And today I'm going to talk about some of the developer tooling work that our team's been doing for the past few months. Before we begin, I want to say that developer experience and user experience are both really important to our team. But today's talk is about developer tooling, so we're going to be focusing on developer experience for the next few minutes. Specifically, we're going to look at the work we've been doing to improve the following 3 areas: speeding up the process of writing components, streamlining the process of debugging and performance profiling applications, and making it easier to stay up to date with the latest React APIs and features. Our work on tooling isn't about adding new capabilities to React, but rather helping you do what you've always been doing faster. Let's take a closer look at each of these areas and what the team's been working on. First, let's talk about how we're speeding up the process of writing components. Those of you that follow React Twitter may have heard about a recent project called Fast Refresh. Let's take a look at a quick demo. For this demo, I'm going to edit an example React component and change a few things about it, like the text color, or the font size, or even the text itself. As I make these edits on the left, the React app on the right quickly refreshes to show the changes. This is all done by Fast Refresh. So let's start by talking about how a tool like Fast Refresh works at a high level. First, it's meant to work in a local development environment with a bundling tool like Webpack, Parcel, or React Native's Metro. These tools are responsible for combining multiple files or modules into a single file and running them through a compiler like Babel. In development mode, bundlers can also watch the file system for code changes and automatically restart the build process. When a file gets changed, the bundler reruns its plugins, which include tools like Babel and Fast Refresh. Fast Refresh processes the updated code, determines if it's a React component, and if so, decides how React should update the component based on the type of changes that were made. Once the change has been processed and compiled, the fast refresh runtime schedules an update with React, so the new code gets shown in the browser or native app. Some of you might be familiar with the term hot reloading. In a lot of ways, hot reloading is similar to fast refresh. Both automatically reload an app when code has changed. So why did we make a new thing? React Native, for example, has had the concept of hot reloading for a while now, but it had a few major limitations. Hot reloading didn't support function components, so no hook support. Hot reloading also didn't recover from syntax or runtime errors. For that matter, hot reloading wouldn't reliably reload after certain types of changes, which may have been because hot reloading was always a bolt-on user space solution that required patches and code transforms to work. So how is fast refresh different? To start, it's now built into React as a first-class feature, meaning that we're committed to supporting it with future updates. It's also built to support all React renderers, which includes React Native, React DOM, and anything else. And it supports function components with hooks, and component state is saved between reloads. So here we have a React component that uses the state hook to increment a counter when touched. If I edit the font weight, fast refresh re-renders the component without resetting its count state. And this is true for any type of edit I would make. Fast refresh also recovers after syntax or runtime errors. So in this case, I'm going to intentionally add some errors to an example component and then fix them to show that fast refresh recovers afterwards without me having to do anything special. So how does fast refresh do all of this? If you're really curious, all the code is in GitHub, but I think it's worth highlighting a couple of the techniques used because they're really interesting. So hook support is probably the most exciting aspect of fast refresh, so let's talk about how it works conceptually. But first, some terminology. When I say update, I mean re-rendering a React component while preserving its state. And when I say remount, I mean unmounting the old component code and remounting the new version with new state. So when code changes, fast refresh has to decide whether it should update or remount the component. To help make this decision, fast refresh computes what it calls a component's signature. This signature is a string that describes which hooks the component uses and in which order. For example, a component that uses React's state and memo hook, like the one above, might have a signature string like this. OK, so fast refresh computes a signature that describes which hooks are used. Why is this useful? Each time the component's code changes, fast refresh recomputes this signature. If the signature is the same, then it's safe to update the component. But if the signature is changed, then fast refresh knows it needs to remount and reset the component state. For example, if we modified the component behind me to replace the state hook with a reducer hook, the signature will change. So fast refresh knows it needs to unmount and remount. This is good because hooks work differently, and trying to share state between them could cause them to break. Under the hood, React stores hook state in an array. Built-in hooks like useState are tracked in this array. Custom hooks aren't directly tracked because they have no state. They use the built-in hooks for this. Because of this, React itself doesn't even need to be aware of a custom hook. For example, here are two custom hooks, useFetch and useSubscription. They both use the built-in state and effect hooks to do something. These custom hooks would both look the same to React, but they shouldn't look the same to fast refresh because it's probably not safe to share state between them. To account for this, fast refresh includes custom hook names as part of the signature it creates. So for example, if we started with a component like this and modified it to return a span instead of a div, fast refresh would preserve the hook state when updating. But if we were to replace the custom fetch hook with a different one, fast refresh would see the change signature and would remount the new component with new state. So in other words, the signature helps prevent the state in our custom fetch hook from leaking into and breaking our subscription hook. Here's another interesting case. What should happen if you change what you're storing in a hook? So you may have noticed that fast refresh's signature includes the name of the variable the return value gets assigned to. That's because if you rename this variable, it implies that the way you're using the hook, what you're storing in it, has changed. Changing the variable name then will change the signature. For example, the component behind me uses the state hook to manage a value named isLoggedIn. If we were to change this code and rename the variable to isLoggedOut, fast refresh would see the change signature and would reset the state. Let's talk about what fast refresh won't do. It intentionally does not maintain the state of class components between reloads. We've learned that it's too hard to reliably hot reload classes without them ending up in an invalid state, so we always remount. And if a module exports both React components and non-React components, fast refresh will always remount the React components to avoid potential inconsistencies. Lastly, fast refresh may also run useEffect and useMemo callbacks more often than React otherwise would. In other words, they may be run even if their dependencies didn't change. It does this to ensure that a component and its internal state is always consistent. Generally, this shouldn't cause problems, but if you think you found one, please let us know on GitHub. At Facebook, we monitor internal usage of developer tools like fast refresh. The old hot reload mechanism was only used by about 15% of Facebook engineers because it was pretty unreliable. Within the first few weeks of rolling out fast refresh, we saw opt-in usage increase to over 50% of engineers, at which point we enabled fast refresh as the default experience, and now almost 100% of Facebook engineers are using it. I'm personally really excited about fast refresh, and I imagine some of you may be wondering when you can start using it too. The good news for React Native developers is that it's already been released with version 61 and is enabled by default. It's the React Native manager there. React DOM support hasn't landed yet, but there's an active GitHub issue with a couple of contributors working on a Webpack integration that could be added to Create React App or other projects using Webpack. And there's an open pull request that adds support to the parcel bundler as well. So we hope support will land soon. Those of you who know me from Twitter know that I like to talk about a few things: making music, going running, my cat Gatsby, and the React developer tools. This year, we've invested a lot in DevTools to speed up the process of debugging and profiling applications. We started with a complete rewrite. Everyone here loves rewrites, right? But they're a serious commitment, because the time spent rewriting old code is time not spent adding new features. So why did we choose to make this investment? The old DevTools had gotten pretty slow. The primary goal of a rewrite was to improve performance so that large apps, the ones that need DevTools the most, could actually run the extension. We also added support for several new React APIs, and the new architecture allowed us to make several user experience improvements as well. Working in an unfamiliar code base is challenging. We've made several changes to DevTools that I hope will help you more easily navigate unfamiliar projects. Let's look at these together. How do you get comfortable with a new project or code base? Getting a better sense of how the code is structured can help. One of the ways to do this in a React project is to look at what each component renders. In this example, maybe the app component renders the navigation component, and the navigation component renders everything else. But in order to know that, I would have to look at the source code for each of these components to see which elements they create. DevTools gives you a way to zoom in on a component and see what it renders. To zoom in, just double-click a component. Now we see only the elements rendered by that component. Double-click another one to zoom in farther. You can use the breadcrumbs up top to step between components. And then when you're done, click the X button to zoom back out to the full application. What do you do when a React component gets past an unexpected prop? Let's say I'm working on a website, and I notice that one of the navigation buttons has a misspelled label. The first thing I would do is look at DevTools. In this case, it shows that the misspelled label is coming in as a prop. So to fix this bug, I just need to find where the bad prop is coming from. I could start by looking at the component's parent and work my way up the tree until I find where the prop is defined. There's nothing wrong with this approach, but it's probably not the most efficient. For example, the menu component might not actually be the thing that rendered the button. It's fairly common to use wrapper elements like this for styling and layout purposes. In this example, to find and fix the bug, I would need to skip over the parent menu component and its parent navigation component as well, and look at the source code of the header component, because that's where the misspelled prop is actually defined. In some cases, this prop may come from even higher up in the application, so tracing through one parent at a time can be a slow process. DevTools makes this easier by showing a rendered by list in the right-hand pane. This list shows which components rendered the selected component and what rendered that component all the way up to the root of the application. It can be hard to explore a big application with a lot of components. To help with this, DevTools provides a way to filter the components so that you can hide the ones you're not interested in seeing, like host components. But we don't have to stop there. Components can be filtered by element type, display name, and source location. Controlling what's shown in the tree makes it a lot easier to find what you're looking for when debugging. If you ever need to go lower level than the DevTools interface, you can log an element to the browser's built-in console. There you can inspect its props and state, see the location of the component source code, and directly interact with the native elements it renders. We've also made it easier to tweak and test React components. One of the ways we've done this is by redesigning the interface for editing props and state. This editor now allows you to define new props and to change the type of props. Any JSON parsable value is supported. And I want to specifically thank an external contributor, Christo, who worked on this feature. Another exciting feature of the new DevTools is that hooks now have the same level of support as props and state. This means that values can be edited, and nested arrays and objects can be expanded. Suspense is React's API for managing dependencies. This can mean anything from lazy loading code to fetching data to loading images. Suspense lets components wait for their dependencies before rendering, and it lets you create custom loading states to be shown while components are waiting. DevTools lets you quickly test these loading states with a new toggle. This makes it easier to design polished visual transitions for your app. DevTools can also help improve console warnings, making them easier to track down. In dev mode, React may log warnings to the console to let you know that something's wrong. These warnings include what we call a component stack string. It's kind of like a call stack, but for React components. It helps identify where in your code a particular error or warning is coming from. Component library maintainers have often requested a way to log their own warnings with the component stack. For example, without a component stack, the warning above could be pretty frustrating to track down. DevTools now provides an option to automatically append this stack to third-party warnings and errors. We hope this will improve the developer experience when using third-party component libraries. All right, let's switch gears for a few minutes and talk about changes made to the profiler. The profiler is a really helpful tool for optimizing React components. The old DevTools supported profiling, but only after it had connected with a renderer. Because of this, there was no way to profile the initial mount, which is one of the most performance-sensitive parts of an app. DevTools now has a reload and profile button, similar to the browser's built-in profiler. This button will automatically reload the connected React application and record profiling data for the app startup. Profiling data can also be exported and shared with other developers to enable better collaboration and debugging. To demonstrate this feature, we're going to export a profiling session from one DevTools window and import it into another. This is also a great way to share bugs with the team if you think you found one. When profiling an app, you might find yourself wondering, why did this component render? The profiler now helps answer this question by recording which props and state changed between renders. This feature is turned off by default because it adds a small amount of overhead to the profiler, but you can turn it on in Preferences. Now let's record some example profiling data. And if you zoom in on specific components, the profiler would tell us which ones are newly mounted and which ones updated, in this case because props and hooks values changed. Thanks. The profiler also now displays a list of each time the selected component rendered during a profiling session, along with how long each render took. This list is a nice overview of the performance of a specific component. There are a couple things that we haven't talked about yet, and I couldn't think of a category for them, so let's just run through them quickly. One small but very useful recent addition that was added to DevTools is that it now remembers the previously selected element when you reload a page. I don't know if he's here, but Dan added this, so thanks to Dan for this. DevTools Search used to show a filtered version of the components tree, which I always found confusing. Search now shows results inline, just like the browser's find in-page search. Higher-order components have been a popular pattern in React for a while now. Higher-order component is a function that takes a component and returns a new component. Before hooks were introduced, higher-order components were one of the most popular ways of sharing behavior between components. DevTools now shows higher-order component names as special badges to make them easier to spot within the tree. DevTools will also now dynamically adjust indentation so that you never need to scroll horizontally. This was a bit of a controversial feature, but we hope it makes it easier for you to browse large trees. Okay, I know that was a lot to cover. So if anyone needs a refresher, visit react-devtools-tutorial.now.sh. This website is an interactive tutorial that teaches some of the DevTools features I just talked about. You can always reach out to me on Twitter with questions as well. Now on to something totally different. Let's talk about the work we've been doing to help everyone stay up to date with the latest React APIs and features. Code mods might be an unfamiliar concept to a lot of people. A code mod is basically a tool that helps refactor large-scale code bases. It's kind of like a much smarter find and replace that's run across your whole project. For example, let's say you wanted to update a JavaScript project to replace all of the var keywords with let, where it's safe to do so. If your code base was small, like a single file, you could probably just scan the file and replace them manually. Maybe even use find and replace. What if your project was thousands of files? What if other people were contributing as well, meaning that you would have to deal with merge conflicts? What if your change got reverted for some reason and you had to rerun it again later? This is where code mods can help. Let's walk through the code mod process at a high level. It starts by reading JavaScript source code from a file. The source code is parsed and converted into an abstract syntax tree, or AST for short. An AST is a tree representation of the structure of a program. Each node in the tree corresponds to an element in the source code. The code mod itself is a small JavaScript program that modifies this tree. For example, a code mod could update this AST to replace all var declarations with let. Because a code mod is a script, it can do more complicated edits than find and replace could. And even something as seemingly straightforward as replacing var with let requires some logic to avoid making unsafe replacements. When the code mod's finished, it prints the modified AST back out as a JavaScript string. A small code mod like the one we just described can be run across thousands of files in a way that's fast and reproducible. So what kind of things are code mods good for? Renaming things, like variables, method calls, imports. They're good for reordering things, like sorting imports. And they're good for certain types of conversions, like updating a component to extend pure component instead of component if it satisfies certain criteria. They're not good for everything, though. For example, code mods aren't that useful for complex behavioral changes, like replacing component will receive props with get-derived state from props. They're not that great at fixing bugs either. A code mod wouldn't be good at making React application code safe for concurrent mode. Tasks like this usually require a more complex decision-making process. I'm mentioning code mods today, because we like when the React community is able to stay up to date with the latest releases. This way, everyone benefits from new API features, and there's less fragmentation for open source maintainers to manage. Code mods help with this. For example, the React team is responsible for updating Facebook's code base when we introduce breaking changes. This can mean updating tens of thousands of React components. While preparing for this talk, I looked back at a few of the APIs I've helped update since joining Facebook, and we couldn't have done it without code mods. Replacing React.PropTypes with the PropTypes package updated over 3,500 files. Renaming unsafe lifecycles updated almost 8,500 files. And replacing create class usage with ES6 classes updated 20,000 files. Don't clap. The reason we're talking about code mods now is that the React team maintains a curated set of helpful code mods on GitHub. We add new code mods to this repo when we introduce API changes that can be automated. We also test and run these code mods ourselves on Facebook source code to make sure they work as expected. Recently, we've made running these code mods as easy as npx react-code-mod. For anyone who doesn't know, npx is an npm package runner that lets you run CLI tools hosted on the npm registry. So let's look at an example. We'll run one of the early React code mods. This one replaces create element function calls with JSX. First, we'll run the code mod command using npx. This will automatically download all of the npm packages required to run our code mod. Then it will prompt us about which parser it should use. And when the code mod finishes, our code will have been updated in place. Let's take a look at it. Let's do another. Here's a more recent code mod that some of you might be familiar with. It renames unsafe class component lifecycle methods. We're going to run this one on a real open source project using an older revision of React Virtualized. We'll use npx, just like before. This time, when it asks us which parser to use, we're going to choose flow. And a couple of seconds later, it's updated all of the locations where the old lifecycle methods were in use. Visit github.com/react.js/react-codemod to see other code mods the React team has published. And if you're interested in writing your own code mods, check out the bit.ly link behind me to see the var to let code mod example that we walked through earlier. I hope you've enjoyed this brief overview of the tooling improvements our team has been working on recently, and we also hope that you'll keep sharing your ideas and feedback with us. And that is my talk. If you have questions, you can find me on Twitter or come talk to me in the hallway. I'll post a link to the slideshow on Twitter, too, for anyone who's interested. And thank you all, and I hope you have a great second day of the conference.
Good job. Yay! Your job would be a lot harder without React Dev Tools, right? Anyone writing React? Anyone here heard of React? OK, so I want to just say something to anyone who's a speaker. If anyone spoke at the conference, we're going to meet up here on the stage at noon for a picture, in case you can get that memo. Everyone else, pretend I just made a really good joke and laugh loudly. Yes. Who clapped the loudest for Brian? So I'm keeping a tally. You all? Okay. Okay, got it. Putting that in the permanent cache. Do you like my dress today? I'm dressed as Treats. Is it better or worse than Pac-Man's suit? What? Yes, better. Yes. Okay, so up next, thank you. Up next is Joe Savona. And here's the deal about Joe. I've known Joe for about 7 years. And the funny story is that, well, we used to work at a company that's different. It's not worth mentioning. But I interviewed him for a position on the design team. And when I was interviewing him, I quickly realized that he knew more about JavaScript than I did, which sucked because I was supposed to be the subject matter expert at that company. And it quickly sent me into a huge panic spiral of imposter syndrome. So I don't write JavaScript anymore. No, but we worked together a while and he found React and was like, Devin, check out this React thing. I think it might be cool. Like it might be something. It might take off. Anyway, look at us now. Joe's favorite food is pizza, which is awesome because pizza's delicious, and I'm surprised that more people didn't answer the question that way. And I have a pizza tattoo. Do you see it? It's a heart-shaped pizza. Anyway, give it up for Joe.
Wow, that's a lot of people. So I tried to think of a good suspense joke. Didn't come up with one. They've all been made. At this point, let's talk about suspense. So I'm Joe. I work on the Relay core team at Facebook. And today I'm going to talk about suspense for data fetching, based on our experience building the new Facebook.com with Relay. So I'll start by giving a quick introduction to Relay, some challenges of data fetching, and to suspense. Then I'll give an overview of the key patterns for using suspense in an application. And finally, I'll wrap up with an overview of best practices for data fetching with suspense. So first, a quick introduction. In case you're not familiar, well, at this point, hopefully you are familiar. People have talked about this in some previous talks, but just in case you missed those talks, Relay is a library for building data-driven applications with React. It allows developers to express their data dependencies declaratively via GraphQL. And the framework orchestrates fetching data and keeping the UI consistent as data changes. So we've talked about Relay before, but over the past few years, we've focused a lot more on Relay. It's used on the homepage of Facebook.com today, and it powers effectively all of the data fetching for the new Facebook.com. We also use Relay in our mobile apps that are built for features that are built with React Native. So I mentioned this not to encourage you to go out and use Relay, listen to this talk, decide for yourself, but to set some important context, which is that many React features like concurrent mode and suspense were built in close collaboration with the Relay team, as well as our web infrastructure and product teams. So these React features like concurrent mode and suspense are designed to work with other data fetching solutions. We're not locking you into using Relay. But there are many lessons from Relay that have informed the design of these features. Together with the React team, we've identified a set of best practices that we think will set the ecosystem up for success in creating great user experiences. These are patterns that library authors can use to build data fetching solutions that work with suspense, and patterns that product developers can use to just build their applications with suspense. So let's step back and look at the problem that we're actually trying to solve. And that's building a great loading experience for our app. That's really what suspense is about. Apps often need to fetch a lot of data to show to the user. And we want to strike a balance between showing information as it becomes available so the user can see something early, while not showing a janky loading experience. So consider the new Facebook.com. A traditional way to load this page might do data fetching when a component mounts. So we'll start rendering the page, some component will mount. In a use effect hook or component did mount, it will kick off a data fetch. Until that completes, it'll show a loading spinner. Then the fetch will complete, and it will show more UI that goes and fetches data, and again and again. So we informally call this the fetch on render pattern. We had a lot of discussion about what to name these patterns. I don't expect you to remember these specific names. Hopefully, just during the talk, it kind of gives you a little bit of a frame of reference for some of the different patterns. So the basic idea of this is we render, and then upon rendering, we realize, oh, we need some data, let's go fetch it. So this can work, but as we just saw, it can lead to waterfalls, where the app makes multiple round trips to the server. and the user waits a long time to see content. So this was one of our motivations for building Relay somewhere in the ballpark of, I don't know, 5, 6 years ago. Didn't used to be called Relay. Used to be a routing framework, and then it turned into a data framework. Again, motivated by this desire to fetch the data for our UI in fewer round trips. So consider implementing a component for this UI to show a single post. Rather than have the component be responsible for directly fetching the data, with Relay, we can just describe the data that it needs. So we might define a post component as follows. And I'll quickly note that this isn't production code. It's a simplified version, but the basic idea is exactly how we write components at Facebook. So with Relay, we can define the data dependencies using GraphQL. And I'm calling a useFragment hook here. So what we're seeing here is that this component, given some post, it needs the title and the body of that post. Once it has that data, it can then render it. So everything about the post is co-located, what data it needs, and how to render it, but it isn't specifying exactly how to go get this data. What that means is that we can then aggregate the data dependencies from multiple components built like this into a single query and fetch it in a single round trip to the server. So instead of multiple kind of waterfalls of loading indicators, we can then do a single round trip to the server, get all the data, show a loading spinner, and then when it's ready, show all the content. So that's a pretty reasonable user experience. It's definitely better than seeing lots of loading spinners all over the place. So we informally refer to this as the fetch then render pattern. First we fetch all the data, then we show a UI. So this lets us design the loading state. We can at least have one initial loading state that we've thought about, and then a final state that shows the entire UI. But it doesn't let us really show too much in the meantime. If you think about it, these two approaches are really extremes on a spectrum. And in practice, we really do want to we want to be able to incrementally render a UI as data becomes ready. And that's what React Suspense is about. It's about showing some of a UI without waiting for all of it to be ready. So for the new Facebook.com, we basically want a sequence like this, and I'll show it again. So we might want, for example, to show the navigation bar in yellow, followed by the left nav in pink, followed by stories in the right content in blue, finally showing feed, the feed of posts from friends and family in green. And the idea being that even if, let's say, the newsfeed were ready first, we wouldn't want to show that first because it would lead to a janky experience as other content loaded in. So now let's look at how we can achieve this type of incremental loading sequence with Relay and Suspense. For the purposes of the rest of the talk, I'll kind of zoom in a little bit on just the newsfeed and the composer, which is where you can write a status update. We'll start by fetching a really simple piece of data. At the top of the screen, you can see we're showing a place for the user to write a status update. We call this the composer. And on the left is the user's profile picture. So we'll need to get what the URL is for that profile picture. OK, so again, we'll define a component, composer. And here I'm calling a useQuery hook. And this hook is actually responsible for going and fetching the data for this component. And I'm using it here just to keep the example simple. In general, we'd actually call useFragment. Multiple APIs that kind of let you scale your app. But to keep it simple, we'll start with useQuery. And hopefully you can kind of imagine what this query returns. It returns an object that has me, photo, and the URI. Given that result, I can pass the URI into an image component and render the image. So useQuery has a few responsibilities here. You'll notice that it's just returning the actual data. It's not returning something that indicates an error, loading, or error. It's just giving me the data directly. So what happens if the data isn't ready or if there's an error? Well, if useQuery isn't ready yet, if it's still pending, if it's still fetching the data, it will suspend. It will tell React, I'm not ready yet, render a fallback. If the query fails, the component will also say, OK, I'm ready now, but when it's rendered again, it will throw an error at the point that it's actually rendered. So what does that mean for using this component? Well, we'll want to render composer, but again, it might suspend, and it might throw an error. So we'll have to wrap it in a suspense component and provide a fallback, We can provide null, in which case React will just render nothing, and sometimes that's OK. But typically, we'll want to provide a fallback. Of course, it could also throw, so we'll want to wrap it in an error boundary to handle the error case. Now, the suspense and error boundary components don't have to be immediate parents of the composer. These could be anywhere above composer in the UI tree. They just have to be somewhere so that we can handle these two cases. But for simplicity, I'm just going to wrap composer directly. So let's look at the APIs that I'm using here. Suspense is a React API that specifies a fallback in case some child or any any descendant suspends. Error boundary is a user-defined component. And I was supposed to change the name of that lifecycle method. It's get derived state from error. You also probably want to implement a component to catch, though, so that one too. So error boundary is a user-defined component. And the reason this isn't a built-in component like suspense is that you typically want to customize how you handle errors. So for example, you probably want to log that an error happened and some details about that error somewhere so that you know you actually have a bug in production. And what we basically recommend is implementing error boundary once and then using that everywhere in your application so you have a consistent experience for showing errors. Finally, I showed use query. That's an earlier version of our relay hooks APIs that fetches data, it suspends until it's ready, and throws on error. OK, so when we define our component in this way, what actually happens when we go to render it? Let's look at the loading sequence. So first, we'll download our code. Then we'll start rendering home. But we'll call useQuery, which isn't ready yet. It has to go and fetch data. So at that point, two things will happen. useQuery will indicate to React, I'm not ready yet. So React will look up the tree, find the nearest suspense boundary, and render its fallback. So the user will see the fallback at this point. Meanwhile, useQuery has kicked off a query and is going to load the data. Finally, useQuery will complete, tell React, OK, I'm ready, try again. React will then render home, and the user will see the content. But of course, we just rendered the image tag, so the browser will then say, oh, I need to go and get that image. The browser will go and load the image, and eventually the browser will then show that image. OK, so let's look at what the user would see. That would look as follows. So first, we'll see a fallback for the composer. Next, they'll see the UI, but without the image ready. And then finally, they'll see the profile image. OK, so that's not a very interesting UI so far. Let's fetch some more data. Relay supports some features to compose data dependencies from multiple UI trees. But to keep things simple, I'm just going to do a second useQuery call to fetch newsfeed. So newsfeed component, it's basically the same setup as before. We call useQuery, again, fetching some different fields this time. I'm fetching the first two items of the user's newsfeed. And for each edge in the feed, I'm going to fetch some data, kind of keeping things simple here. And then, given that data, I'll render it. Just like Composer, this component could suspend. It might not be ready yet because it has to go fetch the query. And of course, it could also throw an error. Now, I don't want to have to wait for newsfeed to be ready to show Composer, for example. So I'm wrapping newsfeed in its own suspense boundary. If I put Composer and newsfeed together, then we'd have to wait for both of them to be ready. Sometimes that's what you want, sometimes it isn't. So in this case, I'm adding a separate suspense boundary. So let's see what happens when we render this. Same thing, we download code, we start rendering. But this time, we're actually going to kick off two queries. Now you might wonder, how does React able to know that there's two queries here? How does that work? So when a component indicates it isn't ready yet, React doesn't just stop there and immediately go and render the nearest fallback. It continues looking at the tree to see if there might be other components that need to be fetched as well that might suspend. So in this case, because Composer and newsfeed are siblings, React is able to reach both of them and kick off both queries. If I did something like make newsfeed a child of Composer, well, in that case, React only will get to Composer, suspend, and stop, and we won't see the newsfeed query until Composer is ready. But so long as these are kind of siblings, React can actually reach both of them in parallel. OK, so we'll kick off two queries. We'll show a fallback. And as each useQuery call resolves, they will inform React, OK, this component is ready, so try it again. So for example, Composer query completes. React will render composer. Newsfeed query completes, React renders newsfeed. So again, what does that look like to the user? Initially, they'll see 2 placeholders. Then composer will resolve, again, without images. The browser's still downloading it. Then feed without images. And then images will load in whatever order they are ready. So, OK, we're getting data, but that's a lot of images kind of loading in at different times. Let's wait for them. So going back to our composer where we were using a standard image tag, right now image isn't integrated with suspense. And now this is something that the React team is considering adding in the future to make image automatically suspend while it waits for the image data to be ready. But that doesn't exist today. So if we wanted to actually wait for the image, we could just replace image with our own component that implements the behavior. So this would be a user-defined component. Look at the source property. Load it, suspend, tell React I'm not ready yet while the image is loading, throw an error if it fails, and then once it's ready, render an image tag. I'm not going to go into the exact implementation. You can look at the suspense docs to kind of see how to implement this. With this in place, though, we get what I think is a lot nicer user experience. We see the same 2 placeholders as before, but now we'll see composer resolve in full with all of its images ready, and the same for feed. So I don't know about you, but I think that's a much nicer user experience. But you might have noticed that I made an assumption earlier. So we're assuming that composer query completes first. But what if it doesn't? Or what if the composer profile photo just takes a really long time to load for some reason? In that case, we might see something like this. Oopsie, composer's not ready. Now, in this particular case, the composer has a fixed height. So it isn't too big of a problem because the UI isn't moving around. But imagine if composer had a dynamic height based on its content. When composer loaded, that would cause newsfeed to shift. So the user's already starting to read this post, and then all of a sudden it moves on the screen because some content is loaded. That's really not a great user experience. So how do we address that? So again, I put these 2 suspense components as siblings because I wanted to be able to render composer without waiting for newsfeed. If I want to ensure that they load in the same order, I can wrap them in a suspense list component. And here I'm using the reveal order of forwards, which means render in the order that the user would see, or would prefer, so top down. We can also specify backwards, so bottom up, and we can also, I think if you don't specify any reveal order, then that will just wait to show everything all at once. I think, pretty sure. Double check the docs. We just use forwards, so. I mean, really, backwards? Sebastian was just having fun. So even if newsfeed is ready earlier, we'll render composer and then newsfeed. Now, if composer and newsfeed happen to be ready at about the same time, React doesn't immediately render a component as soon as it's ready. It'll actually wait a brief period of time to see if any more content might become available to try to reduce the number of independent paints to the screen. So if composer query and newsfeed are ready at about the same time, we might actually just see it go from 2 placeholders to everything on the screen right here. So to review, the API that we're using here is suspense list. It's a React API that lets you control the order in which sibling suspense components resolve. Now, so far, we've looked at how we would load data for a single page. Next, let's look at how we can use suspense when loading data for a new page, for page transitions or things like modals or tooltips. For example, if I click on a user's name, their profile page. So let's look at how we might fetch data for this. If we still use the same pattern, if we call that same useQuery API, how will this end up getting loaded? Well, we've already looked at it. We'll have to download the code, then start rendering, then go fetch the data, and so on. What we realized is that even though we were using Relay and we were aggregating data dependencies for a UI tree, we still had that same pattern where we had to render in order to figure out what data we needed. The useQuery API was still implementing that same fetch on render pattern. The ideal middle ground, though, is to fetch the code and data in parallel and just immediately start rendering. Just whatever data we have, we'll render it, and we'll wait for whatever isn't ready. We call that render as you fetch. And again, this is not really a term that you need to remember. really, this is what React Suspense is about. It's about rendering data for rendering a view as the data becomes available. So far, I've shown this use query API. But as we just saw, it doesn't make our page transitions as fast as we would like. We'll have to download the code, start rendering, and only then go fetch data. So we've actually renamed this API internally to use lazy load query to indicate to developers that this is actually doing some work lazily and it may not be what you want. And we've largely migrated to a variant of this API that supports this render as you fetch pattern, and we think works a little bit better with concurrent mode and suspense. The idea is to decompose use query into two pieces. The first is preload query. This is an imperative API that will fetch data and give us a reference to the results, not the actual data. And the idea is that we don't want to call this during render. We want to call this in the same event handler that would trigger the display of new UI. So if a user clicks on a link and we're going to navigate to a page, that event handler where we handle the click, that's where we want to start preloading the query. If we hover over something that will open up a tooltip, it's that same hover event that triggers showing the tooltip. That's where we want to call preload query to get the data for the tooltip. The second piece is use preloaded query. It accepts the results of the preload query call, but it isn't actually doing data fetching itself. It's just looking at what the current state of that result is. Is it ready? OK, great, I'll return the data. If it's not ready, it suspends. And if that query has failed, it will throw the error. But the key is that no matter how many times we render, this hook is just looking at the state of that fetch. It isn't actually going to trigger new fetching. So it's efficient and it's predictable. So for the profile page, instead of calling useQuery, we would change to calling use preloaded query, and instead of passing variables, we'd pass in a query reference that we got from somewhere. But where do we get that? So internally, we have an API that we call entry points. And we're working to make this available in open source as well. But the idea is that we want to somehow know, OK, we have some UI we want to navigate to lazily, a modal, a route. And we need the code and the data for it, and we want to fetch both of them at the same time. So an entry point kind of gives us that, a description of that. The root property is the root component that we want to show, so the profile page in this example. And this JS resource call here is our internal API for bundle splitting. So this is just giving me an object that I can use to download this code when I need it. The second piece is this get preload props function that takes some parameters. So in this case, it might be the parameters for the profile route. If I had a modal, it would be some parameters for what to show inside the modal. And it returns an object that maps keys to values of things that we might want to fetch. So in this case, a query, the profile query, and we're saying basically that query reference will be a query that fetches profile query where the ID is the ID from the route. So in this case, like whose profile are we going to? So don't worry if you don't follow this exact API. It's more about the idea of the pattern. So given this definition of a code for a view and the data that it needs, and the actual parameters, we can pass that to prepare entry point function, which actually downloads the code, downloads the data, and then we can start rendering. And take that query reference, pass it to use preloaded query, and render the UI. So let's look at how that affects the loading sequence. Before, we did download code, then start rendering, then start fetching. Now we can download code and data in parallel and hopefully show a result to our users much earlier. So next, let's get a bit more technical and look at how this is implemented. So first, we'll look at implementing the useQuery API that I showed earlier. I think it's especially interesting to understand this if you're thinking about writing a library that will actually will do data fetching that works with suspense. There's a few challenges with implementing something like useQuery in concurrent mode. And these aren't, I want to be clear, these aren't problems with concurrent mode. I think it's very easy to look at this list and say, wait a minute. This is really about, we kind of realize we're not actually doing the right pattern. We really want that render as you fetch pattern. So we tried, but the first thing is like, oh, well, like we can just suspend when we're not ready. So isn't this is really convenient? But then we realized, oh, a component might render multiple times before commit. It might render without ever committing. If that happens, there's no cancellation or cleanup hook. Wait a minute, maybe there's a way to identify a component uniquely, and so we can figure out if we still need its fetch or not. But nope, we don't have that either. We asked the React team, hey, can we have a cancellation and cleanup hook? And they said no. We asked them a few more times, and they said no. Future speakers note there's a gap between the thing up here, so I keep on falling. So we were kind of like wondering, okay, what do we do here? This it was kind of challenging to implement. We don't want to fetch too often. So if a component renders multiple times and we call useQuery again, we don't want to keep on refetching the same query. That would be slow. But if we cache that result for too long and the user comes back 10 minutes later, that data might be stale. So we have to kind of strike the balance of caching the data that we might need, but not caching it for too long. Now, we came up with a solution that works pretty well. But part of the reason that we've renamed this API is, again, it works. You can do this, but it doesn't necessarily lead to the best user experience. Again, we saw how that render as you fetch pattern lets us fetch data much earlier and then show content much earlier. Turns out the preload query and use preloaded query style API is also a lot easier for developers to understand. They want to understand, when am I going to fetch data? If they need to, like something has happened, they need to refetch. They want to know, is this actually going to refetch, or is it going to end up cached for some reason? It also makes it easier to think about how long we're going to hold on to that data. And we can do things like cancel a previous fetch. So imagine a tab component that, as I change tabs, will call preload query for that tab. Well, if I click on tab A and then click on tab B, that component knows, well, I don't need the preload query from A, and I can cancel it. I can stop doing any work associated with that fetch. If the tab component unmounts, again, it can cancel whatever it's currently fetching. It gives us a clear lifecycle for that data. And then use preloaded query doesn't have to worry about being rendered multiple times or cleanup or any of those things. It can just look at the current state of the query that it's gotten from above. If it's ready, return the data. If it's still pending, suspend. And again, this makes it a lot easier to explicitly refetch. We just call preload query again and use that new value. So it's simpler to implement, it's more predictable, and it can be more efficient. Now you might say, but that use query API, that seemed kind of convenient, right? Like it just gets data. And it is. Developer experience is certainly important, but what's really important is a great developer experience in service of a great user experience. The use query style API, where we just fetch data as we need it, it definitely makes it really easy to get started, and it can be fine for smaller applications. But if you really want to show a great user experience to users, the pattern that I've described, we think works better. So wrapping up, best practices for data fetching with suspense. The render as you fetch pattern is about starting to load resources before rendering, and then we suspend if they aren't ready yet by the time we do render. We can use suspense at key points in our application for staged loading, and we can use suspense list for in-order resolution of blocks or lists or blocks of elements. Finally, we can use suspense not just for code, not just for data, but for assets, things like images or any other content that you need to download asynchronously to render your UI. There's a few APIs I'm not covering here that support more sophisticated use cases, use transition and use deferred value. You can read about them in the docs. But before I wrap up, one more thing. Today, I'm excited to announce that we're releasing an experimental version of relay hooks. It's the same optimized compiler and runtime that we've had for the last few years with Relay Modern, with a new hooks-based API. It's battle-tested on the new Facebook.com. It's suspense and concurrent mode compatible out of the box. In fact, we've been designing relay hooks in close collaboration with the React team, iteratively changing both Relay and React to make sure that we could build great experiences. So relay hooks includes the preload query and use preloaded query APIs, as well as the use lazy load query API that I showed. So you can actually look at these APIs, look at the implementation, and see for yourself. It also includes the used fragment hook for co-locating data dependencies in your components and aggregating them, and as well as hooks for refetching data and for paginating over lists. And coming soon to open source are support for defer, stream, and data-driven dependencies, which Ashley showed yesterday. So whether you're interested in using Relay or you just are looking for a solid reference implementation of data fetching with suspense, we encourage you to check out the code. Try it and give us feedback. Thanks.
Isn't Joe awesome? Yeah. He's smarter than me. The struggle is real. Y'all having fun so far? Feeling, yes. Okay, who clapped the loudest for Joe? No one. What? Oh, that guy. Okay, cool. You remember yesterday how the wind was real high and we couldn't play out on the lake? Come on, everyone get gassed up right now. I want to woo! Woo! This is, yeah, there you go. Woo! Woo! Maybe we can start like a wave. You guys know at sports things, they go like this. You want to do it? Okay, so we're going to start over here, and we're gonna go all the way through the crowd. And when my arm is over you, you're going to reach your hands up and go like this, right? We're going to do a wave, okay? Starting at Brian. Here we go. Yes! That was incredible. Woo! Okay, here's the deal. The lake is open today, and it is warm outside, a lot warmer than it is in this room, which is not hard to achieve. So I think that we should have, you know, a paddleboard off, right? Or something today, some sort of water sports, spike ball. Yeah, we're going to do it. Okay. Man, you all need to get gassed up. Do we need some like coffee in here? We need some cheer. We need some general holiday cheer. It's fine. Okay. Oh, the Halloween mask. Yeah, it's still up for grabs, but no one's won it because you guys are being really boring right now. Okay, next up is Cameron. He is really awesome. We've chatted a bit backstage. He really enjoys Junior Mints. Any fans of Junior Mints in the audience? Yeah. That's like my grandma's favorite candy, so I get it. He said he didn't enjoy chocolate, and so Junior Mints were like his transition into chocolate. So I can appreciate anyone that transitions to chocolate in that way. We really enjoy it. He's going to talk about visualizations, which is always a passion of mine, so give it up for Cameron.
Let me see if I can maximize that. Great. Hello, everyone. Please raise your hand if any of this sounds familiar. Have you ever worked on a project with more than one file? And then, have you ever drawn rectangles and lines on a whiteboard somewhere to explain to somebody how those files worked? Nice, so many people. And then, have you ever felt like saying, I've fallen into my code and I can't get up? If not you, maybe a teammate. So I've been there, and I think there's a better way. In this talk, we're going to explore how the world of generated visualizations of front-end code could make developer experience just a little bit better. So to understand the origins of this idea, you should know I've always liked pictures of how pieces of a system fit together. In electrical engineering, we had circuit diagrams with both an abstract and a physical view. As a data engineer, I leaned on Airflow's task dependency diagrams to show how pieces of a data pipeline fit together. Currently, I work at Datadog, where we make tools for visualizing data about your cloud infrastructure. This is a view of our network topology graph, which shows you throughput and how different pieces of your system talk to each other. But I also like to explore this sort of thing in my free time. So I take the train every day, and this is the Metro North Rail in New York City. And I reused a technique from 19th century France to see which tracks and stations are busiest. And unlike the paper version, because it's React, you can filter and regenerate the graphic anytime the underlying data changes. I also experiment with making data-driven thank you cards for the interns on our team, because usually when you leave, you don't get to keep your data. So this is generated from people's GitHub and Trello data, and everybody gets a unique snowflake. I'd like to open source this soon, so stay tuned. But let's talk about why you also might want to have some automatic visualizations in your life. It's pretty simple. I think feeling lost in your code feels really bad, and there's no 911 for you to call. And there's so many ways in which this can happen. When you switch to working on a new feature, which just went from prototype to prod, so there's no documentation, or you're poking at the internals of some new NPM dependency. Maybe you're on call, and the stack trace puts you into an area of code you've never been in before. Let's think about how we get unlost when we're in the real world. First, you wander around, you look for landmarks, and these help you orient yourself. You might ask for directions, hopefully from someone who knows their way around and isn't a tourist as well. But most of the time, you have some sort of map or a GPS, which shows you both where you are and where you might go next. Let's compare this to the code world. So we also have wandering, but it looks a little bit different. You're scrolling in files, you're using Control F, maybe you're using grep, and your signs look like comments, or maybe a README. You can also ask for directions. You can use git blame, maybe your project has a code owner's file, and you look for an expert in your feature. But when it comes to maps, we don't really have a GPS, there is no Google Maps. And this talk was born from a desire to explore how we can make the code world just a little bit more like the real world, at least for mapping. So there are many types of data visualization that could help us, but we'll focus on maps. And many people fixate on it being something from the physical world, but I just like how it's a graphical representation that lets you think about something as if it took up real space, because our brains like metaphors a lot. Now, for a map to be effective, it has to be abstract. The only way to include every single detail would be to just look at every single line of your code. And that doesn't save you any time. So to be useful, a map must leave information out, and that's considered a feature and not a bug. So modularity and information hiding are important in software engineering, but we see this in maps too. So Massimo Vignelli spent 8 years redesigning the New York City subway signage. And part of the project was to make this schematic diagram of the subway lines. And this diagram focuses on information that you can see when you're underground, but it skips all the details above ground, like where the streets are. Now, it's a really clean design, and it's informed by user research, but it's not the map we use today. This is the actual MTA map. It conveys information about above ground, and it reveals to you that the lines are not perfectly parallel to each other. You might be asking, which map is right? Well, it depends. More information isn't helpful if it's irrelevant to what your users are trying to do. So a good design is going to be informed by the specific problem that your readers have. In other words, I'd say that neither map is correct, because the ideal abstraction level is going to be situation specific. With this in mind, today we'll focus on the information that you need when you're going to change your code, whether you're adding a feature or fixing a bug. It's not just about getting to a destination. A good map provides you with information that you didn't ask for. Because when you're lost, you don't know where you might need to be cautious. In other words, I'm talking about the dragons in your code base. So think about the parts that are waiting to bite the next person who joins your team. Maybe it's a function that depends on a global. Maybe it's a file with no test coverage. But maybe having a visual aid to organize this information could be helpful. So here's our plan for today. We're going to look to the past. We're going to go to the 90s. We'll move on to some tools that you can use right now. And we'll look to apply some newish ideas from outside the world of software to the diagrams we saw earlier. So in preparing for this talk, I spent a few weekends reading some HCI papers, looking at how people study developers as they change code. And this one comes from Jimmy Koppel. To provide some context, let's address the main concern I hear when I first tell people about this idea of a code diagram. Usually I hear something like, my project had an architecture diagram at the start, but then we built it just a little bit differently, and then nobody went back and changed it. And the diagram never got revisited because, just like a bad translation, an incomplete or a misleading map is worse than not having one at all. So the software reflection model paper from 1995 addresses this head-on. The authors propose a technique in C and Java to bridge the gap between source and high-level models, and it was used to help refactor Excel, which is millions of lines. Before we go through an example, here are the steps. So first, you'll draw a concept model, which looks a lot like the flow charts that you might be familiar with. Then you'll relate each of those concepts to files in your project. Then you'll run some sort of automated dependency extractor, and then you'll combine those earlier 3 steps and highlight the differences. Now, I want to spend a little bit more time before we see an example of why these differences are so important. I think this is where bugs hide. Because when the relationships in your mental models do not match what the code is actually, how it's actually connected, you're going to have a really hard time solving your problems. And you'll probably introduce bugs when you're trying to fix things. So here's an example reflection map from one of Professor Murphy's slides. On the left, here we have the plan, and on the right is what actually happened. But to make this a little clearer, I'm going to walk you through a small React example. So here we have a concept model of the container view pattern that we heard about from Becca and Tanya yesterday. Each of these edges represents an import. So we have our container, which holds our business logic and some state. We have our view function, and the intentionally vaguely named data API. That'll become important later. So here's a little bit of code for each of those concepts. We have our data fetcher, we have our view component, and we have our container component, but don't worry about the lines. I'll post them later. We then turn the reflection crank. So you make a regular expression, mapping each one of those files to your concepts. Then you run a dependency analysis tool. And because this is a greenfield project, everything lines up, hopefully. And in this case, it does. Everything matches. But let's consider what happens a few sprints later. So a new API was added, and someone tells you they did some refactoring. But all your unit tests still pass because you're testing the interface, which is the container. So maybe everything's OK. So here are the changes. Once again, don't worry about the lines. But like I said, some functionality was rearranged, and some new things were added. So we turn the reflection crank once again, and our graphic is quite different. There's an edge we didn't expect, and an edge that we thought would be there is gone. So reflection has shown us that there's been a gap between our plan and what we meant to do. So what happens next? Well, there's a choice. Well, first, you can have a conversation with your teammate about what exactly data API means. Like, should it be for network things, or should it be for data processing? But then you can choose to rearrange your code, or you can redraw your diagram. Neither one is correct, per se, but now you can decide. So this technique is especially useful when your system has many parts. The first step to solving any problem is defining the problem, and these diagrams help you define the problem graphically. So if we reconsider our original question of how we minimize the gap between our plan and what is made, well, we've learned at least 2 things. First, we shouldn't fixate on whether the plan or the code is the source of truth. Seeing the difference is the important part to getting things to line up again. And secondly, what I really like about this approach is it plays to the strength of people and machines separately. Right? It addresses this is out-of-date problems faced by hand-drawn diagrams, and it solves the show everything but it's chaotic problem faced by auto-generated programs. So humans and computers are good at different things, and reflection lets each party focus on their respective strength. We're going to jump forward in time a quarter century and examine what we can use right now in the React ecosystem. Specifically, we're interested in tools that help us to keep our visual plan and our code up to date without the annotation steps that are required by reflection, because I promised you automatic. One way to think about this is to use a language that looks just like your plan, because they can't diverge if it's just the same thing. This thinking guided the design of some signal processing languages and in visual programming. We'll look at two small examples. First of these is MaxMSP. It's older than JavaScript. You have blocks that can make audio signals and transform signals, and you can mix and match them. And seeing the plan laid out this way makes it very approachable compared to the equivalent text-based code, even though you can still make very advanced music and sounds. Then there's Mimu, which is open source and entirely runs in the browser. And a nice feature here is at each block, you get a preview of what happens to the data that flows through it. You could have a whole talk just about visual programming, but they won't help us with our existing JavaScript applications. So I'm going to change our question a little bit. We're going to focus on the visualizations that we can make from our existing code. It turns out there are many tools out there, and they generate some form of directed graph, visualized as some form of node and link diagram. If our edges have some sort of direction, we can say it's a directed graph, and if there are no loops, we can say it's an acyclic graph. Every time we draw an edge, we're just saying some node uses another node B. But I'm leaving the question of what a node means a little bit open-ended, because this is situation-specific. We don't have to choose one thing. And we can lean on how we treat political abstraction in this same way. We go from continents all the way down to neighborhoods with many steps in between. And we don't need to worry too much about actual landmass when making this ladder, because even though states are lower on the ladder than countries, you can fit the United Kingdom into Texas. So similarly, let's not worry about whether a component is fitting into one file or it's in 4 places and they're imported by a root. It's the conceptual boundary that matters more. We're going to walk down this ladder from general and go down to specific. So tools at every rung of this ladder are all helping with variations of the same question. If I change a node, what other nodes could be affected? Our first stop is where we treat each node as a file. So there's Archit, short for architecture, not the augmented reality tool. You'll get a module dependency graph. It's powered by GraphViz. Every time one of your files uses the import keyword, a new edge appears. As your graph gets busier, you may want to group the related nodes. So here, everything that's an NPM dependency has been put together. If you don't have time to make custom groups and your project folder structure is very well organized, as everybody's is, you can use Dependency Cruiser. It'll group your nodes based on what's already put together into the same folder, and you can even write import-based linting rules. And lastly, we have Madge, the module dependency generator. And a nice idea here is that we've colored our nodes differently based on their graph properties. So our nodes, our root nodes and our leaves are shaded differently. It has a very extensible API, so we'll see it more in our demos later. The next rung on our ladder treats functions as our nodes. And these graphs aren't necessarily DAGs because we permit recursion and looping. So we've seen performance graphs like this several times already today. But each one of these things is a dynamic call graph. This is a snapshot of how your functions actually ended up calling each other. And our x-axis is encoding real time. But there are variations. If it looks like this, it's a flame graph. If it's upside down, it's an icicle chart. If you wrap it around a circle, it becomes a sunburst. But they're all variations on the same thing. The difference between this and the previous one is that the x-axis encodes duration rather than absolute time. So if a function has been called multiple times, they'll be bunched up into a single block. So you've traded some summary information in exchange for having less information about control flow. But let's say you want to see everything that could happen instead of what actually happened. And for that, we have static call graphs. This is an example from Python called Pyan, and it shows theoretically every possible route. Now, I don't know of any open source tools that make something like this for JavaScript, but if you're interested, there is a data structure library which can generate these things for projects that don't have Webpack and aren't using TypeScript yet. So if you'd like to contribute to an open source project after this presentation, I recommend building on top of JS call graph. So at the bottom of our ladder, let's treat variables as our nodes and make some data flow graphs. One place that embraces this is the observable notebook. If you haven't seen it before, it's a reactive environment for writing JavaScript, combining some of the best ideas from Jupyter Notebooks and Excel. So just like React and Excel, you don't have to tell specific cells to rerun if you update a dependency. The dependents just rerun automatically. But you can't see those relationships just from scanning. So Observable is made by Mike Bostock, who also created the D3 data visualization library. And being the person who likes visualization that he is, he made a tool that lets you debug any observable notebook by generating the data flow graph for any URL that you pass in. So each oval is a cell in your notebook, and the dependency lines tell you what cells will rerun if you change some other one. And he actually uses screenshots from this tool to help people when they have questions in the forums about why things are happening. So here's a data flow diagram used with reselect, which is a helper library for memoizing and composing selectors. If you're not familiar with it, you can check it out in the Redux starter kit that Mark Erickson launched this week, which is the official set of libraries for making Redux development easier. Each one of our nodes is a selector function, which is a function that takes in state as an argument and computes for you some new derived state when an upstream dependency has changed. But keeping track of these dependencies can get out of hand very quickly. So this is wrapped up inside something that looks like the Redux DevTools, which is because it uses the same components. And we have 3 details we haven't seen yet. One of these is if you click on a node, we highlight the ancestors and the descendants. You can also see the value of each selector at runtime, and you can count how frequently each node has been used, which helps with performance profiling. I had to mention one more approach to modeling computation, even though it didn't fit into my ladder, because it enables some really spectacular visual tooling. I'm talking about state machines. It showed up on one slide yesterday very briefly, and luckily I didn't talk about it anymore because I get to tell you more about it. But the nice thing is it gives us automatic visual documentation. So state machines are a model for computation where a system is a list of states and a list of ways to move between it. The important thing to take away here is that the diagram on the left of a traffic light is generated from the thing that looks like JSON on the right. And you can take this picture to your PM or your designer and work together to find edge cases, even if they're not familiar with JavaScript. Once you have a machine, you can plug it into an ever-growing number of visualization tools. So sketch.systems is one where you can write something that looks a lot like YAML and is very concise, and you can generate a clickable document on the left, and it'll actually generate XState code for you to plug into your React applications. There are actually many more tools that we didn't have time for, but it's time to look to the future. For this last section, I explored some ways in which we can extend what we've seen. I picked 2 ideas to experiment with: hairball untangling and wayfinding. And these are challenges that I felt were important after reflecting about why I wasn't using all of these things in production already. So in this case, a hairball is not something that a cat coughs up. It's a network graph that's too tangled to read. Drawing large directed graphs that remain readable is really hard. And in bioinformatics, they've developed some new layouts to deal with this. We're going to focus on just node link diagrams today. I really think we need to solve this because if you don't manage a busy diagram, people don't take it seriously. If you have something that's up to date, but people can't understand how it helps them, it's almost worth like not having it at all. So I'm going to reframe our question once again. Rather than asking, how do I see everything, we're going to focus on which parts do I actually need to see right now. So we're going to borrow a page from the world of cartography. I'm going to show you a series of maps, 4 panels, gradually zooming into a city. So at the country level, you barely see the state outlines. As you zoom in closer, you get state labels, you get highways, and eventually you get streets. And this progressive reveal approach limits information density so people don't get overwhelmed. How do map makers do this? Well, they have this thing called a map taxonomy chart. It's a very detailed document where you outline exactly what labels and what concepts you can see at every zoom levels, and they do it for 16 layers. We're a little bit of a ways off from having our file imports and our call graphs and our data flow all in the same diagram. But for now, we can look to this idea when we reduce visual noise even at one layer. A design pattern for managing information throughput is the information-seeking mantra, coined by Professor Ben Schneiderman in '96, and has 3 parts. Overview first, zoom and filter, and details on demand. So if a picture's worth 1,000 words, a prototype's worth 1,000 meetings. And so I've made a demo to illustrate the ways in which these ideas can be combined with the MAJ diagrams we saw earlier. I made a demo Electron app to help me find my way in 2 open source projects that I looked at recently. JS Network X, which is for network analysis, and Interact, which is a React-based Jupyter environment. So the first idea was to take the file dependency diagram and make it clickable with 2 tweaks. So first, since it's an overview, I can take the labels away and everything gets equal visual weight. And secondly, I added some colors to separate our island nodes and our regular nodes from the roots and leaves that were already shaded. And this helps me find entry points, because that's the starting point of any new code base code spelunking. The next idea was to let the user make the tree smaller by removing the nodes that aren't relevant. Since we're clipping branches off a tree, I call it pruning. There's a heavy prune where you can remove entire folders, and a light prune where you take one file away at a time. And this is our chief flexible defense against the hairball. If you get carried away with your pruning and your tree looks like Charlie Brown's, every click generates a regular expression under the hood. So you can go back and edit the regular expression, or if you don't like clicking and you just really like configuration files, you can jump straight to the menu option. But once your graph is pruned, layout algorithms that wouldn't have made any sense on the full graph can become practical. So here we have a hierarchical layout that wouldn't have worked on the main tree, so the modules that have the most children get floated up to the very top. For the last stage of the mantra, I focused on details about individual nodes. So if you click on something in the main map, you get a mini map of that node and all its neighbors one hop away. And I found this useful when the graph was very busy and I wasn't sure where to prune, and I needed to walk a local subnetwork. But this metadata doesn't have to be graph-related. Any tool that gives you more information about some file can help. So I used git log, where you can get the most recent commits for any file, you can group them by author, and you can sort them by the most recent modifier. And this might help you with the finding directions step of getting unlost, so you know who to ask. The second idea that I explored was motivated by having a map, but not being sure where to try to go when I was in it. And architects think about this all the time through a subfield called wayfinding. Wayfinding covers the techniques that people use to figure out where they are and where they need to go. It's very popular to have projects like this for hospitals and airports, because these are complex spaces where people are frequently entering not very often, they're under time pressure, and there are high safety and monetary costs to going to the wrong place. This felt to me like being on call, so I took a closer look. There are several core questions in every wayfinding project, but today we'll just focus on selection. And this is based on how I felt after looking at my own demo. I had this automatically generated map. I knew how to make it less busy, but I wasn't sure which parts to spend more time in. So my idea to do something about this was to just add some data, and maybe the usefulness could grow. This is kind of the same reason that most of us look at geographic maps. You don't really look at them to remember how the states are shaped. You look at them to put data into spatial context, right? So weather maps help you decide whether you're going to cancel a trip, and flight coverage on a map is much nicer than looking at a list of coordinates. We see this idea in other software tools. So when I worked on data pipelines, one of the best things about Airflow was you can see the success or fail status of every part of your data pipeline right on the graph instead of getting a printout of log messages. And in our call graphs, you can count the number of invocations, or you can count total runtime and display this on our nodes and links instead of putting it into a table. So for this second demo, I was inspired by location-based search tools like Yelp and Google Maps. Because on one side, you get your list of search results, and on the right, you see those results overlaid onto a map. This demo works on non-JavaScript projects because I'm just leaning on your folder structure. So on the left, I've put the JS Network X algorithms folder flowing from left to right. And let's say you want to find all the to-dos in this part of the project. So I connected it to ripgrep, which is the Rust-based speedy grep. And I've highlighted all the places where to-dos appear in the project. I also keep in two ideas from the mantra in our first demo. We keep the map interactions where you can pan and zoom through your folder tree. And then if you click on a node, you see the actual lines that showed up in each one of those files. In the future, I'd like to combine the information from the folder graph with the dependency graph, and then maybe weave in some messaging data, so we can see if Conway's law about how software shape mirrors organizational shape is actually holding. So while I work on making some documentation for these demos, let's step through the main takeaways from our tour today. We started by looking at the reflection model. This approach combined our human ability to make abstract concept maps with the thoroughness of machines, and we highlighted the places where our plan and what was made ended up being different. And this can help us debug and communicate with our teams more effectively. Secondly, we walked down a ladder of tools for building some sort of dependency graph. We worked at many layers of abstraction. We saw over 9 different tools, and they'll all stay up to date at the press of a button if you point them at the right source file. So please try these out with your teams. And lastly, we looked at some tools or ideas to make those graphics a little bit more actionable by adding some interaction techniques guided by the information-seeking mantra and the idea of layering data on top of our maps so we have some more context. I'd like to leave you with a quote about why I think working on tools that make code visually understandable is so important. First, we shape our tools, and thereafter, our tools shape us. If we spend less time trying to figure out how our code works, we can apply that energy to focusing on more important problems in the real world. As Tom said yesterday, our better DX is in the service of delivering better UX. So while I don't have a crystal ball, and I don't know what that new efficient shape will look like, I'm optimistic that spending less time being lost will leave us happier and with more time to help other people find their way. So I'm planning to open source the demos. Please send me your screenshots and ideas for improvement. But thank you for listening, and reach out to me if you have questions. Thank you.
That was perfect. Didn't he do a perfect job? Woo! Okay, it's time for a break. Everyone go outside, have a coffee. I want everyone in this room to give a high five to someone else, okay? And I'll see you back here at 11. Yeah. Yeah. I saw the line at the coffee stand, so I know that you all are amped up. I see them. Yeah. Coffee cups everywhere. Yeah. Coffee cups in the air? Yeah. Those are my people. I can smell you. Okay. So the conference organizers see that the luster is dimming in the crowd. We would like to bring your attention to some really cool things that are happening in the corner of the foyer. Some craft-related events. There's some cool things, some little calligraphy, little adult coloring books, some really cool things if you don't feel like smiling or talking to anyone else, but want to sit adjacent to someone doing something creative. One of the coolest things is that there's miniature painting. What is miniature painting, you might be asking yourselves? It's exactly miniature painting. You take a miniature, like dragon or dinosaur, and you paint it with a tiny paintbrush with coloring paints. And there's a man out there who's an expert on such things. He's ready to mansplain exactly how to paint these tiny little figurines. So if you're not stoked about sitting in this room anymore, though, can I just, do you feel that in the air right now? It's the not air conditioning. Right? Yeah, we really had to work hard for that, but we made it happen for you. But anyway, if you're still feeling yuck in here, there's big TVs in the outside room, so you can watch the talks and paint miniatures while watching the talks. See how to react with the miniatures. Ayo, yeah, you got it, landed. Okay, so here's the deal. We're gonna have another talk. Jen, who really enjoys Reese's Peanut Butter Cups. Can I get a hell yeah for Reese's Peanut Butter Cups? Recently at work, I bought a bunch of blonde peanut butter cups. Okay, so at work, sometimes it's boring, so I buy everyone candy kind of constantly to keep them jazzed up, as one does as a senior engineer. And I bought a bunch of the blonde ones, the white chocolate Reese's Peanut Butter Cups, and people are pissed. Like, these are not real. How dare you? Anyway, so that's my life. Give it up for Jen!
Hello, everyone. I'm really excited to be here today to talk to you about React and fiction. So, as noted, I'm Jen. I have been described as very cool at programming, and I am currently a front-end architect at The Wing. I also co-organize Use React NYC, which is a meetup for React enthusiasts in NYC. And if you want to reach me on Twitter, my handle is girlcode, girl with a U. And being described as very cool at programming, having the role that I have, I really still marvel at where I am today, because I started my career on a very different path. You see, I've been writing for as long as I can remember. I even owned a typewriter at 8 years old. I begged for it for Christmas. And I would sit in my room, crafting characters, designing plot lines, and dreaming of the day I'd be a published writer. In college, I majored in English and creative writing, and later I worked days as a paralegal while earning my MFA in creative writing part-time. Okay, well, I only owned a third of it. I actually dropped out of the program. People tell you you're going to be a starving artist, but it really doesn't sink in until you get your first student loan bill. So, yeah, I left the program. But I don't regret it, because I had a second interest growing up, and that was code. So when I left creative writing, I left it to pursue engineering. Now, it is a longer story than that. These are the cliff notes. But what's important is the transition, because people, whether fellow engineers or not, are often surprised by my background. To them, these two disciplines, writing and coding, don't match. And for a long time, I thought so too. So when I decided to pursue engineering, I put everything that I knew about creative writing in a box, and I closed the lid. And years went by, and I left the box alone. 3 years of working with Vanilla.js, jQuery, and Angular 1 went by. Box stayed closed. And then about 5 years ago, I started writing React. And there was this immediate affinity. Writing React to me felt like coming home. It was really familiar in a way that I couldn't pinpoint. But I also felt a tension, because how I wrote components felt off somehow. Here I am following the conventional wisdom on what makes a good component, and it felt wrong. And then the light bulb went off. Writing React reminds me of writing fiction. That's why I'm so comfortable with it. And I'm violating creative writing tenets. That's why this feels so wrong. So I started writing components with these tenets in mind. And what I found was leaning into what I knew about writing well helped me write better components. Like show, don't tell. So show, don't tell is one of the fundamental creative writing principles. In fact, it's known as the golden rule. Its purpose is to encourage description over exposition, show being the description and tell being the exposition. So if we look at a sentence like she is tired, we can identify this as exposition. The sentence is instructional. View the character as tired. That's the instruction. And that's the basis of telling. It's providing instructions on how to view something. It's direct. Showing is indirect. Her footsteps are heavier than before, the weight increasing as she trudges towards the bed, collapsing face first onto the mattress. So this is a dramatic shift from exposition to description. You still know that the character is tired, but that information is inferred from context. And notice that you can feel it more. Words like trudges, descriptions of heaviness, collapsing, you can feel the character's tiredness. And that's why writers use this rule. It pulls the reader in. It lets them feel what's happening. And what I love about show, don't tell is how it maps to React's declarative, not imperative approach. So telling is instructional. Imperative code instructs. Showing is descriptive. Declarative code describes. When I talk about the comfort that I feel with React, its declarativeness is a large part of that. And when I talk about the tension I've felt coming from a writing background, it's because I knew at some level that how I wrote components violated show, don't tell. And this was true of other tenets of creative writing as well. Because again, I thought that writing code and writing fiction had nothing in common. So I want to take you through what happens when you write a component with these tenets in mind. And I also want to illustrate how thin the divide is between code and creative writing. Because here's what we are going to write today. It is a navigation header or navbar, and depending on whether the user is logged in or not, they're going to see a different UI. So for logged out users, there are 2 links, spaces and happenings, and the login and sign up links. And if the user is logged in, there are now 3 links: home, happenings, and community, as well as an avatar and a drop-down menu that appears when you hover on that avatar. Now, one of the first things that we're going to do is start to determine what individual components we need. Writers do this as well. Joyce Carol Oates has this really lovely advice: be alert for the possibilities of paragraphing. I really love that sentence. It's just beautiful. And what it's pointing to is structure. Writers care a lot about structure. There's an art to grouping words and sentences, to creating breaks in paragraphs and in dialogue. And that can be said of components as well. So when we're looking at a design, we're actually looking for the possibilities of paragraphing. What should be a component? Now, one possible component breakdown for this is a navbar component, which we'll use both for the logged in and logged out states, and then a profile drop-down component. And I'm not going to go too much into how we could rearrange all these things. I'm just going to say this makes sense, actually, so let's just go with it for now. And we're going to build our components out. We're not going to build it out all right away, though. We are going to put in some placeholder pieces. So what I'm interested in seeing is the structure we create and what information we need. So first, we'll be holding our navigation inside a div. That's the main container element. We're going to put a placeholder for the logo for now. Let's not bother with that yet. And then below that, we're going to place a nav element, and let's leave a placeholder for the links. We're going to deal with those in a minute. But now we're left to decide how to show what UI. Because remember, we have the sign up and login link or the avatar and drop-down menu, depending on the state of the user. So it seems that our best option here is to use a prop to denote whether the user is logged in or not. If the user is logged out, we'll show the login and sign up links. If the user is logged in, we'll show the avatar and the drop-down menu. Now, looking at this, what we've created here is a terrible first draft. All good writers write terrible first drafts. It's how they end up with good second drafts and terrific third drafts. I really love this, and I love this because it's all good writers. Now, Anne goes on to say, people tend to look at successful writers who are getting their books published and think that they wake up every morning feeling like $1 million, feeling great about who they are and how much talent they have, and what a great story they have to tell. That they take in a few deep breaths, push back their sleeves, and dive in, typing fully formed passages as fast as a court reporter. But this is just the fantasy of the uninitiated. You are now initiated, so let's not pretend. Our first drafts are terrible, all of us. Which means that this isn't going to work out. We need to take a second look. Now, that doesn't require starting from scratch. Second drafts build on first drafts, third drafts build on second. So our focus here is really, what can we keep? What can we rework? It's really likely not obvious at first, because we've got this bare bones component, so what even is there to work with? Well, if we're following the principles of creative writing, I can tell you that we already have a violation. It might be clearer if we look at it like this. This is our navigation component in use, and as we previously outlined, we need an isLoggedIn prop. IsLoggedIn is our instruction to this component. It's telling it to render a UI, which means that we violated show don't tell. And I see this problem often. We use props like is something or has something to denote what to render. We use if, else, and ternary statements to conditionally render our UI when we should be breaking it out into separate components. Looking at these designs, we think that there is enough in common between the two that we can reuse the same component for both. And I understand that thought. I have had that thought. And the reason I've thought that is because I've been trained to look at components like this, distilling specific parts down into generic pieces. And what you see here is the similarities. Both designs have logos, they have links, they have some other form of functionality towards the right. And this is a good technique for understanding component architecture, but it's really not the whole story. Because every character should want something, even if it's only a glass of water. What we're defining here is character motivations, what the character wants or needs. Narratives aren't formed from plot. What's happening around your characters is less valuable than what they want or need and how that aligns with their behavior and their actions. As readers, we're willing to suspend our disbelief for well-written and motivated characters. We know when a character's motivations are mismatched with their behavior. It pulls us out of the story. And that's why this isn't the whole story. We aren't considering the motivations. If we look at the shared motivations, what each component wants to give the user, we find there's not much in common here. The differences outweigh the similarities, which means that this should be two components, not one. So in our second draft, we're going to create two components, a logged out navigation and a logged in navigation. Now, to save some time here, let's pretend that there's already a logo component that we can drop in. So with that done, we're going to turn our focus to the navigation links. Now, one option here is to create a reusable nav component that can be used for both the logged out and the logged in navigations. But to do that, of course, we're going to have to dynamically compose links. Remember that the logged in and logged out navigations are different. As a logged out user, you're going to see spaces and happenings, and as a logged in user, you're going to see home, happenings, and community. So we have a difference here in both content and in length. Now, to handle this, we're going to rely on setting our links with an array of objects. Each object defines the link's name and its toLink. And then in our reusable component, we'll use the array to create the links. So for each object in the array, we'll return a link component with that object's to and name values. And what's really nice about this approach is that we're limiting repetitive code. And it also solves for the unknown because it can dynamically create the links. So this component can actually be reused no matter how many links there are or what their content is. And this is really convenient because this design is full of links. So we're going to get a lot of reuse out of this one small component. In fact, we can use it for our next piece, which is the login and sign up links. Except, okay, we do have one small hiccup. So we were creating our array of objects, and what we found out is that the login link actually isn't a link. So it's actually going to be opening up a modal instead. It has an action. So we need to make a decision here. We have this nice reusable component, and we want to keep using it, but to do this, we're going to need to incorporate some changes. And so the question is, do we want to do this? If we're looking at our design, though, what we want to incorporate actually makes sense. So we want this component to work for all the links. And if we look at the menu and the dropdown, we actually have these same needs. So profile and settings are true links, but logout is going to be performing an action. So it'll log the user out and then redirect them to another page. Since we need this, let's go ahead with our revisions. We're going to add an on-click key, which will store a function as its value. And in our reusable nav, we'll look for the to key. If it exists, we're going to pass back a link component. Otherwise, we're going to pass back an a tag with an on-click set to our specified function. So now we're going to add another reusable nav to our navigation component. And notice that we're passing down both the nav links and what I'm calling the action links. So again, we're getting maximum reuse out of this component as well. If this logged out navigation needs to be reused with different links, we can do that. So we might be feeling pretty good now because we're done with this. Except this is the part where I tell you what we think we did and what we actually did aren't the same things. So we think we created two reusable components. But what we did is this. We chose an abstraction to make things dry. We kept that abstraction, expanding it to take on more and more outcomes because we value reuse. It is how we weigh a component's worth. It's also how we unintentionally create components that are difficult to understand, difficult to use, and difficult to change, which is why you should write what you know. Write what you know is arguably the most well-known rule in creative writing, and it's often misunderstood. So it doesn't mean that you look around and you write that. It means that you write what you know to be true. So applied to components, this is even more concrete. If you know what a component needs and what it should render, then write what you know. I used to value reuse above all else. I thought components needed to be as reusable and configurable as possible. And what I ended up doing is wasting time on problems that never appeared. So if we write what we know, this is what our logged out navigation looks like. So we have two links, and then we have the a tag with its on-click set. And I find this cleaner. I find this easier to understand. And I also find this more prepared for the unknowns. So let's imagine that our design changes, and now we need to add an icon next to the happenings link. With our previous abstraction, we would need to modify the object's details to include an icon key. And in the reusable nav, we would need to check for that key and conditionally render an icon, all for one icon being added to the design. And you can see now that it really doesn't take long for this pattern to break down. It's fine for 1 or 2 use cases, but as you add in more, it's really creating more complexity than it's solving. But if we don't commit to this abstraction, if we write what we know, the modification is one step. Add the icon to the happenings link. Now, the downside of this is that you are going to be repeating yourself. And I know that we are trained to keep things dry. Don't repeat yourself. But repetition is not your enemy. Writers know this. His heart was going like mad, and yes, I said, yes, I will, yes. So I really adore this line. It's the last line in James Joyce's Ulysses. If you study English, you are like required to read Ulysses like 6 times or more. It's a very long book too, and it's very difficult, but I promise you it's actually worth it for this last line. It really is. So Joyce's use of repetition here, the word yes, coming back again and again, I mean, this is masterful, really, truly. This is known as one of the best sentences in literary history. And, because the word's coming back again and again, this yes, it gives this sense of hope and anticipation. And without it, this sentence is really ordinary. It's really nothing special at all. You see, writers know that repetition is a tool. Repetition of words, phrases, descriptions, writers use these to create emphasis, to create structure, to build on the previous. Writers repeat on purpose. And we can use this lesson in our components. Repeat on purpose. Repeat because you want to avoid the naive abstraction. Writing components as a mechanism to dry your code is often just that. Very few writers really know what they are doing until they've done it. We often pick abstractions well before we know what we're doing. And that's why write what you know and repeat on purpose are useful guidelines as you start out. And this is true of writers as well, because these rules that I've mentioning, these tenets of creative writing, they act as guidance for improving as a writer. Think of them as training wheels to keep you at least upright, if nothing else. The true balancing will come later with experience. Now, I have some more thoughts on that, but first, I want us to finish what we started. There is one more piece to write, and that's the avatar and the drop-down menu in the logged-in navigation. Now, recall that back at the start, we wanted to make this a separate component. And I still think that's the right move here. So here is our user drop-down. It's going to encompass a separate avatar component. We're going to need some state here to track whether the drop-down is open or not. And then we're going to set the avatar's on hover handler to toggle that state. If the drop-down is open, we render a nav element. And for the links, we're going to continue to write what we know. So this is our finished user drop-down. And we're going to add it to our logged-in navigation. And now we're done. No tricks this time. We are done. We can move that ticket into the done column. And now we move on. Remember that sooner or later, before it ever reaches perfection, you will have to let it go and move on and start to write the next thing. Like writers, we often need to move on before what we've written is anything near perfect. Our time is finite. Which often means that from time to time, we are revisiting our old, imperfect ideas. A component we aren't particularly proud of, a snippet of code we can now see should be structured a little differently. We might feel unease about refactoring these because it's an admission that something didn't work. But rewriting is the essence of writing well. No work of fiction that you have ever read came without the cost of painful, sacrificial revision. Honestly, truly, if you think I am exaggerating, I am so not. Writers absolutely hate revision. They absolutely hate it. But it is the path forward. You cannot improve without it. Refactoring is not failure. Get comfortable with it. Take something you built and rebuild it, then figure out why it's better or worse. Take something someone else built and rebuild it, then figure out why it's better or worse. I could tell you to follow everything that I've said here as gospel, but you know what? Break the rules. See what you learn. This is how writers become writers. And what we are doing here is a craft. I used to think that writing and code had nothing in common. But the truth is that we are both building something from nothing. And in our worlds, there is no win and no fail. There is only make. Thank you.
Thanks so much. How's everyone doing? Yeah. Woo! Woo, 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 woo. Okay, so here's what happened. I went outside just to check on the miniature mansplaining, and I got this tiny little witch. She's really tiny, and she has bangs, and she's a software witch just like me. It's pretty cool. Anyway, I'm gonna paint that later if y'all wanna hang out and paint that with me. Also, while I was out there, they have all these like kinetic sand boxes and rose quartz sand boxes for you to play with if you are feeling stressed out or maxed out on social capacity, as I am. And there are also keychain making stations with little React logos that you can make your own keychains or a bracelet if you want to, but mostly keychains if you want to participate in that sort of like Girl Scouts of America fun times out there. It's gonna be good times. Also, lunch is coming up, so we're gonna have some snacks, snack time, and then we're gonna party a little bit more out on the lake. No? Yeah, okay, it's fine. You don't have to come. It's just me. It'll just be me and Esme. What's her name? Okay, so up next is Alex. I'm pumped about Alex. You're pumped about Alex. She likes York peppermint patties. I think those are like the nanas of Junior Mints. Junior, it's like the Papa Bear to Junior Mints, right? Like if Junior Mint had a dad, it would be a York peppermint patty. Anyway, this is gonna be awesome. Alex is awesome. Everyone scream for Alex. It's gonna be a great time. Yay.
Hi, my name is Alex, and today I'm going to be talking to you about building mobile-first web animations in React. So what's a mobile-first animation? I like to think of a mobile-first animation as having three main characteristics. So first, it takes inspiration from design patterns found in native apps, especially thoughtful use of gestures. Second, a mobile-first animation is developed on a mobile device, and it's intentionally designed to work within the context of a mobile browser rather than a desktop one. And finally, a mobile-first animation has great performance, so it works just as well on a mid-range Android phone as on the latest iPhone. So why should we care about this? Native apps use animation in ways that enhance the user experience by creating really fluid, intuitive, and gesture-driven interactions. And there's really no reason that we can't strive to create experiences of a similar caliber in our React web apps. So it doesn't even need to be particularly difficult to apply some of these patterns. So here's a pattern that I'm calling horizontal snapping scroll, and you see it really everywhere on mobile. It's image carousels, tabs, cards, but you see it a little bit less on the mobile web. And for a pattern like this that might not even qualify as an animation, we can actually apply it just with CSS. So there's a scroll snap type property that's pretty well supported in Android and iOS. And on the right, I have the reach tabs component. and I've wrapped it in this CSS to the left with a little extra JavaScript, and I have pretty easy native feeling tabs, which is cool. I will say that scroll, snap, stop, which gives you a little extra customization ability, is only supported in Chrome right now, so definitely look into this and make sure it meets your use case. But I was pretty excited to learn that I could implement this effect with just CSS. Here's another pattern that you see a lot on mobile, swipe to dismiss. I'm a UI developer, and I think a lot about the way users interact with the apps I build. So I think about button presses, form controls, clicks versus key press, that kind of thing. But until recently, I totally ignored gestures. And swipe to dismiss is a really ubiquitous gesture that it kind of makes sense to be aware of. And one of the things that I think is pretty interesting about it is it comes in a lot of different forms. So it's not really just something that could be implemented by a single awesome React component. It's maybe something that you want to be aware of how to implement from scratch. So I decided that I was going to build some animations to explore implementing swipe to dismiss on the mobile web. And I built these 3 examples, and we're going to sort of use them to learn some techniques and performance optimizations as we go on in the talk. So my first attempt at building an animation was an animation inspired by the Apple Music app. And I was feeling pretty good about myself when I implemented it, because it looked pretty good as long as I stayed in Chrome DevTools. And here it is. I thought it was pretty nice. I could use my mouse to move the drawer, and I was happy. So I was looking forward to trying this out on a mobile device, and I had just purchased like a cheaper Android phone that I could use as like a testing device. So I loaded it up, and I was pretty shocked at how truly terrible it was. So I noticed like a few issues. I mean, at least a few. There was really low frame rate, so there was like jank and a lag. There was a lot of interference from default browser behaviors, like scroll and swipe to refresh. There was a sluggish response to touch, so I didn't feel like I was directly manipulating what was happening on the screen. And finally, this one's a little bit harder to explain, but it just didn't feel native. It didn't feel like a good animation. So the first thing I want to say is that some of this could have been avoided if I'd just been using a mobile device as my primary development device from the beginning. And ideally, this wouldn't be like, if you have a fancy or high-end phone, you might have an average device that you can use to develop on instead. So I got a Nokia 6 from Amazon. I think it was like 100 or 130 bucks, and I now use that for animations. So it turns out also that it's very easy. Say you just want to look at localhost on your phone. Create React app has been showing me for the years I've been using it, that you can just go to the local IP on your network, and you can see localhost there. I had totally ignored that this was even a possibility, but this is a really easy way to check that whatever you're building works on your phone. And if you want to get a little fancier, I actually prefer USB debugging, which is nice because you don't have to be on the same network. And Chrome DevTools gives you some nice extra stuff, like you can use like the debugger. So that's a workflow tip. In general, I don't want to talk too much about implementation, because the truth is we're really lucky in the React community to have several great animation libraries that we can use to implement these animations, and it's not that difficult. So I just want to go through like a few options. There's Framer Motion, which is a really great, a little more all-in-one solution. And if you're like a beginner in animation, this might be the one you want to look at first. There's my personal favorite, React Spring and React Use Gesture, which is a little more like composition-based, or gives you like a little more power. It's a little more hands-off. But you don't even have to use those two, which are like the most high-profile React animation libraries. You could use React Swipeable and combine it with vanilla.js animation library like Anime.js that works pretty well with React. Or you could use a sort of battle-tested gesture library for vanilla.js called Hammer.js and combine that with whatever animation library you want. So I don't really want to talk too much about implementation, but I do just really want to really quickly walk through some code to show you that it is pretty easy, and then we can move on to more complex topics. So here, let's build this little like dismissible notification with React Spring and React Use Gesture. And this code is a little bit simplified, but it gets the basic idea across. So we're going to import our hooks, use Spring, and use drag. We're going to set up our Spring. So we're just animating a single variable y, which is basically going to be translate y like 100 pixels, or 0 to 100 pixels, and that will be when we dismiss the notification. This is the use drag hook, which gives us some helpful information. Every time a gesture progresses, we're going to get information about how many pixels the gesture has moved. We can get information like the velocity of the gesture, but here we're doing something very simple. We're just checking the movement y, and we're setting the spring to correspond with that. And if it's the final gesture, which is denoted by the last variable, we're going to decide whether to animate the notification closed or pop it back open. And finally, we just render our notification. We take the onTouchStart listener from the bind function, and we use this like React Spring way of adding our animated opacity and transform values. So that was it. That's how we can render this component. So hopefully that showed you that getting something to move on the screen in React in response to a gesture is pretty easy, but like doing it well is a little bit harder. So I want to take a look at scroll, which is like one of the most basic interactions on mobile, and see what insights we can take from scroll and apply to our own animations. So the first insight is that scroll has an immediate response. It's not really an animation, it's a direct manipulation. And here's a quote from a talk called Designing Fluid Interfaces that was given in 2018 at the Apple Developers Conference. If you're interested in these ideas that we're talking about, I really suggest you check it out because it's really fantastic. So in the talk, one of the speakers said if you do introduce any amount of lag, things all of a sudden just kind of fall off a cliff in terms of how they respond to you. There's all this additional mental burden, and it feels super disconnected. Here's a little illustration of that. I've done a lot of animation on desktop, and to me, on desktop, the left, or the stiff spring, looks fine, maybe even better. But on mobile, we really want to have that one-to-one movement to feel like we're directly manipulating what's happening on the screen. So we don't want to tween the position of the component. We want to have the one-to-one movement. OK, so here's a concept that's a little more complicated. So we can look at scroll decay to help us actually decide how our UIs should respond when a user interacts with them. So you might have used this CSS snippet WebKit overflow scrolling touch to get nice momentum scrolling on an overflowed container. So on the left, we have the default in Safari, which is that as soon as you pick up your finger, the scroll animation stops. And on the right, we have it with momentum scrolling applied. I think in Android, it's by default with momentum scrolling. But yeah, so how is this implemented? Momentum scrolling uses decay. And so I've used like easing functions before for animations. I've used springs, but decay was a new concept for me. And rather than deciding on a fixed endpoint, what decay does is every frame reduces the velocity until the component comes to a stop. And iOS has two default decay rates that you see on the right. There's normal, which really takes a long time to settle, and fast, which is a little bit shorter. So we can use this idea of decay to kind of predict what our users intended. On the right, we have an example that I implemented that has basically 3 potential endpoints from a gesture. The user could have decided to cancel, like maybe they didn't actually want to delete or see an archive option. They could open the 2 buttons, or if they swipe hard enough, they can just directly delete the email. And so Apple's talk gives this little snippet that's pretty interesting called a projection function. And we can basically just take the velocity of the gesture, and we can decide how far this component would have traveled if it was being scrolled rather than animated. And we can use that to inform what we do with it. So here I have a little demo, and we're going to use projection to show the endpoints of the, I guess, list items. So we can take this information, and then when we, oh, that one went a little far. So basically, we use that number, and we decide, like, is it closest to the end, to the archive and delete button open state, or to the full delete state. And that helps us combine information about velocity and gesture distance in ways that make sense to our users. This one is a little bit simpler and more fun. I think rubber banding is something you see, especially in iOS a lot, for scrolling. So rather than having a hard endpoint when a gesture completes, it slowly increases the friction. So it's kind of like gives you a soft indication of where the boundaries of your animation are. So I've used a clamp function a lot when I do animations. Clamp is just take a value, take a min and a max, and make sure it's in between those two bounds. That's like really standard. But we can use a rubber band function instead to make sure, so I'll show you. It's not very interesting, but it just stops there, and it stops there, and it doesn't go beyond. But when we add rubber banding, we can make sure that all of the boundaries are sort of gentle. We can add a little squash and stretch if we want, and this is like an effect that's used really commonly on native as well. Okay, so we were looking at how an animation should proceed while the gesture is in progress. But at some point, someone is going to finish the gesture, and then what do we do from there? Let's look at how we use springs to make sure our animations work well. So luckily, I don't think I have to like argue that springs are good for UI animation, because that's been a thing in React since React Motion. But I just want to review them really quick in case you haven't used them in a while or used them yet. So the first thing that struck me when I learned about springs was that they're bouncy. And I think that's the first thing that a lot of people notice. So here I have a little demo of the image grid component. And this is what it looks like by default. So I have the damping ratio of the spring set to no bounce. So there's no bounce there. But we can edit this. We can set it to infinite bounce, which I do not suggest. Let's stop that. But yeah, so in general, I think it's really tempting when you learn about springs to like want everything to bounce, but it really doesn't have to. We can still get a lot of benefits from springs with zero bounce. One thing I did think that was interesting that Apple suggests is using no bounce if it's a tap-initiated animation, and then adding a little bit of bounce if it's gesture-initiated to give a little more movement. So that's bounciness. One of the more interesting things, I guess, is that springs are interruptible. And this is true for desktop animation as well. But when we're building animations for mobile, we really want to make sure that at any point they can be canceled or redirected. It's really important. We don't want to like have to have the user wait basically until the animation completes. And springs help us with that. If we were to use, I'm going to set the frequency response. We looked at damping ratio, which controls the bounciness, but I'm going to set the frequency response, which controls the speed of the spring, and I'm going to take it from like a normal speed to something super slow. And this is great for developing because you can actually just pressure test and make sure that you can fully interrupt everything at any time. So like maybe if the user just misses but then decides they do want to see the thing, you can make sure that that all happens in a fluid way. And the reason springs help us do that is because they're like physics simulations, so they're not. I've used a lot of like CSS easings in the past where you decide in advance on a timing, and springs don't do that. They just take the position and the end position, and then they calculate like how long it should take. So we're not stuck in like always animating something at the same duration, and it feels more natural. And the final thing that I want to talk about with springs is that springs have velocity. And this is really important for our animations. So the material design guidelines say that when animating an element to a destination, the speed of the user's gesture should be matched by the speed of the element being moved across the screen. Here I have a little simulation of this. We have the gesture velocity set at gentle swipe, but if I move it to crazed fling, you see that the animation changes, and all I'm doing is sending a new velocity into the spring, and it goes faster, and there's a little more of an overshoot, which is great. I didn't have to do anything or change any setting, and it responds to the input that the user is giving. So if I were to change that to ease out, no matter what like velocity I set it in, that's not going to change the nature of the animation. So this isn't really great. That wouldn't be great for gesture-initiated animations. All right, so that was the animation best practices part. What did we learn? We learned to look at momentum scrolling as a reference point for the behaviors of our animations. We learned that our animations should really be interruptible and redirectable at any point, which is facilitated by using springs. And finally, we learned that spring animations initiated after a user finishes a gesture must accurately reflect the velocity of the initiating gesture. So now let's look at browsers. So it's fun to like think about making the perfect animation in isolation, but eventually we have to like actually implement it in a mobile browser. And it turns out that if we're doing gestures especially, the mobile browser already handles a lot of gestures, such as scrolling, swipe to navigate, pull to refresh, and so on. So we could build the best animation ever, but if it's interfering with what the user actually wants to do, it's going to be bad and probably not worth it. Here's just one example. So like on a mobile browser, you can swipe left and right to navigate. This has been a thing in Safari for a long time, and it's behind a flag in Chrome, but it's a gesture that we have to be aware of if we're going to do any horizontal swiping. So luckily, there are some techniques we can use to make sure that our gesture-driven animations coexist with the browser really gracefully. And the first technique is called hysteresis, and this is a UX term borrowed from the physical sciences. And I think it was originally used in UX maybe to denote that tiny period of time in between when you move your mouse on a mega menu before the menu closes to see if you're going to scroll over some other, or scroll over another part of the menu. So it basically describes intentional lag. And during that lag, the system is getting a little more information, which might be information about the timing or the distance or the direction of a user gesture. So on the right, we have this email list component, and I'm scrolling it up and down in this video. It looks like I'm scrolling side to side, but I'm not. I'm just not able to scroll at perfect 90-degree angles, so I'm unintentionally triggering some animations. And we definitely don't want to do that. So we can add a bit of hysteresis. Here I have a simple function that's basically just ensuring two things. First, the gesture is over some threshold that we've decided on. I'm going to say 15 pixels. And second, it's more of a horizontal movement than a vertical movement. So we can just sort of use a net to catch anything that we don't think was meant to trigger our animation. And with that, we've totally fixed the problem. It's very easy to scroll, and you can trigger the animation if you want to. So hysteresis is easy. Touch cancellation is a little more complicated. When I was first implementing these animations, I thought, OK, cool, I'll just use event.preventDefault. That's what I've used that a lot of times. It should totally work. But unfortunately, we can't really use event.preventDefault for touch listeners. And that's because it requires us to add a non-passive event listener, which is going to kill our scroll performance potentially on mobile. I was a little dubious about this because I really wanted to use event.preventDefault and just move on with my life. So I tested it by adding non-passive touch listeners. And you can see, hopefully, on the left, that it really slows down the scroll. So it's not worth it, because our whole point is trying to increase the interface responsiveness. So if we're hurting performance to do that, it's not worth it. So luckily, CSS has a property called touch action that we can use instead of event.preventDefault. And so touch action all is like the default. Just let the browser handle everything. Touch action none completely disables all browser handling of gestures. The ones that you'll probably be using the most are touch action pan X and touch action pan Y, which basically whitelist browser handling of gestures. So pan X is going to disable vertical scroll, and pan Y will disable x-axis gestures. So I was excited to learn about this, and even more excited to learn that we can actually use it, because it was recently introduced in iOS 13. So of course, some browsers still don't have it. For instance, those stuck on iPhone 6s that will never be able to upgrade to iOS 13, which is what I have, but I'm not bitter about it. So let's move on. So touch action is really cool, and I want to show one way that it's really cool. It's smart. So on the left, I have touch action all, and much like the hysteresis example, the user is trying to scroll left and right, but unintentionally they're doing a little bit of vertical scrolling. And touch action is smart enough to realize that if we've triggered a horizontal movement, we should fix the scroll and disable it until the gesture has completed. And that's actually kind of difficult to implement without touch action. Here's another example of touch action. It's a little more straightforward. So if you disable scroll, a lot of browsers will still respond to your up and down gestures by showing and hiding the address bar. And we can disable that by doing touch action none on the component that's being moved. All right, so what did we talk about? We talked about using hysteresis to make sure that our users won't trigger animations unintentionally. We looked at the touch action CSS property to disable default browser behaviors with precision. And finally, we made sure that we would be aware that mobile browsers have a lot of differences, both in the types of default gestures they implement and their support for properties like touch action. All right, so the final section is performance. Even after implementing some of the things we talked about, the performance of this animation is still pretty bad. You can really notice the lag. And I just want to be clear that I love animation. I look for any excuse to implement them in my own work and at work. But it's really not even worth it doing any of this if your time to interactive is bad and your basic performance metrics are bad. So here's a site that I will not name that I put through the Chrome's Lighthouse audit, and they told me that time to interactive is 10 seconds. I think good is something like 5 seconds. So that's definitely something I should fix before adding animations. But that said, how do we do performant animations? The first tip I have is it's cliche, basically. If you've read anything about performance in animation, you know that you should only be using GPU accelerated properties like transform, just transform and opacity. And that will really make a big difference. It's not just something people say. It will definitely improve the performance of your animations. The second tip is also super simple. So basically, the fewer things you're animating, the more likely you are to hit 60 frames per second. So if you're implementing an animation, think about the minimum amount you can do to still get a nice effect. And maybe you can build from there, but on mobile, you should stay simple if you can. So we were talking about 2 tips to make sure our frame rate is fast as 60 frames per second. But what happens right before the animation starts? Google advises that we keep our response times with under 100 milliseconds. And I was finding in 2 of the 3 animations that I implemented on the lower-end phone, I was not meeting that. So I was noticing that there was a really perceptible lag between when I initiated an animation and when it started. Just to make sure that I wasn't just thinking about this and making it up in my head, I ran the Chrome performance profile, which showed me that indeed there was a pretty long response time, something like 200 milliseconds. You can see the frame rate really drops when all the JavaScript is being run. So I wanted to figure out how to reduce this, obviously, and my first idea was to look for unnecessary React component reconciliation. And the new React DevTools have this really awesome feature where you can highlight updates when components render. So I turned that on, and I saw that indeed, when I was just clicking on a component, absolutely everything was re-rendering unnecessarily. So I wrapped the components in React.memo and reran it in the DevTools just to check that things had stopped re-rendering. And I could see that now I was only re-rendering the component that I had tapped, basically. And it felt a lot faster. And when I reran the DevTools, the performance profile, I could see that, in fact, the delay had dropped to a really reasonable 60 milliseconds. And the animation was feeling a lot more fluid, a lot more responsive. All right, so that's my talk. What are the main takeaways? First, develop directly on a mobile device. And if you're concerned at all about performance, ideally on a non-high-end phone. Second, start simple and take inspiration from UI patterns in mobile apps. So if you're in doubt, refer to scroll as a basis for how things should move on screen. And finally, when you're adding a gesture-initiated animation, first consider how it will live in the pre-existing world of browser gestures and how you might apply the techniques of hysteresis and touch cancellation. So here's our drawer. On the left was the before. On the right, we've applied all the techniques. It's a lot more responsive. The frame rate is good. And it just feels a little more native. This talk made use of a lot of resources, so I have them in the slide if you're interested in exploring anything further. And if you'd like to look at the slides or the code, you can do so here. So thank you.
Great job. Animation. Speaking of really dope animations, there's been a lot of tweets and inquiries about this awesome business that's been happening over the last couple days behind me. Y'all love this? Yeah. So that guy, he made all of these by his own self. And what we're going to do at the end of the conference is we're going to package them all up and tweet them to share with you for backgrounds or whatever you might want to use them for. So that's cool. That'll be a little parting gift for everyone. Also, I want to let you know if you need to exchange your T-shirt, lunchtime will be the last time that you'll have the opportunity to exchange T-shirt sizes. So if you need to do that, you do it now. Speakers, we're going to meet up here right after everyone departs to do a couple picks. And now it's time for lunch. So I'll see you back here at 1:30. Okay, everyone? Hello. Hi. Did y'all get some candy? Yeah? If you didn't get some candy, there's giant buckets of candy over there. Go grab some candy. That's my gift to you. They were like, okay, so what had happened was that they called me and they were like, we want you to MC. And I was like, okay, let me come up with a theme and an idea, which was food and candy, as you might have guessed. And I was like, so day 2 of a conference always gets a little Debbie Downer. It's hard to get people to show up. And when they do show up, they're kind of napping in the audience or like just counting the minutes until they can get out of the conference, even though the content is so good. But one of the cool things about candy is that it makes you happy. A couple black beans in my burrito, too. Anyway, we're going to have a great afternoon. It's about to get crazy in here. Yeah, I know, exactly. A couple little things that you might be interested in as the day progresses. We're continuing to do arts and crafts outside. I started painting my little witch. That is a very big investment. But you can watch the talks from the TVs out there while you're making a keychain or painting a tiny turtle with a man on his back. Anything that you want to do. It's really your heart's desire. It's a lovely little introverts table over there, actually. People are just quietly painting to themselves and every once in a while whispering, can I please have the scab red? Because the paint colors are named like weird things like bloody toes blue and like I hit my thumb green or something. I don't know. It's really, they're cool. And then also on top of that, there in the next room over Casablanca, some people are hanging out from various developer teams. The React Native team is hanging out over there. If you have any questions about React Native or need some help pairing on something, just go over there and you can hang with them or ask them a question. And then after that, we're just gonna be in here rocking, until the sun comes home. So what we're gonna do right now is another bang, bang, bang session. You remember bang, bang, bangs from yesterday? Okay, so to recap, it's 20 slides in 20 seconds, 20 slides in 20 seconds. 20 slides in 20 seconds would be really rough. Okay, it's 20 slides, and then each second is 20 minutes. No, okay. 20 slides, each slide is 20 seconds for a total of 6.5 minutes. Okay, so we're gonna have 4 people come up and do that. It's Jay, Juan, Jen, Kyle. First is gonna be Jay, and we're gonna bang, bang, bang through them. So after everyone gets up, you're gonna clap, you're gonna scream for them. It's gonna be awesome. Remember, the sloth mask is still up for grabs. No one has impressed me thus far. Okay, so everyone give it up for Jay.
How's everybody doing? Let's do this. All right. So I sold millions of records, and I have over 10 years, or well over 10 years of software development experience, and I'm going to tell you why they are the exact same thing. Show of hands, who here is a musician, artist, DJ? Oh my gosh, that's crazy. If you're live streaming, that's like 100% of the people, just to let you know. All right. So a little bit about me. My name is Jamel Johnson, a.k.a. StatCash on GitHub. I have a lot of sysadmin experience, also some front-end development experience, app architect, as well as a team lead, avid debugger, and even more avid rebugger. So really, really happy to be here. But also, I'm known as J Dash. I'm an artist, producer, songwriter, and composer. My song, The WAP, recently went double platinum in December. Thank you. Appreciate it. I licensed a lot of music, TV and film, and also in December recently scored my first film called 83 Days, which nominated for 15 awards and won 10. So, programming, does that equal hit records? Not really. It's actually more of a one-way street from what I've seen, just because really great musicians also tend to make great programmers. If you're a great coder, it doesn't mean you should pick up a guitar and you're just going to immediately start shredding. So, not saying that you shouldn't, but just from what I've seen in the 10 minutes of free time I have to make this presentation. So we're going to look at a few ties that kind of bind the two things together. First being orchestration. To work on specific aspects of compositions require the composer to hold the remainder of the musical structure in their imagination. It's a great quote. And it's something that developers and musicians do every day, right? I mean, you guys write components that have to be a part of a larger structure, and you have to learn how to orchestrate. The next thing, recognizing and manipulating patterns. Musicians enjoy the why and how of music. They can learn to ask the computer the same types of analytical questions we've been asking ourselves of the music for years. It's something that you guys do all the time, especially the guys that do these Rubik's Cubes here, which I'm sure there's a few. Understanding how patterns work, design patterns, as well as musical patterns is pretty much the same thing. Spatial and temporal skills. So both music and programming are very regular and mathematical in nature, yet contain a strong element of artistic creation. I guarantee if I asked a bunch of you in here if you feel like what you do is very robotic or more artistry, I can almost guarantee you have a bit of that art connection to your code, right? So kind of the same thing. Also, you're great individuals and collaborators. So you're really good at what you do individually, but at the end of the day, if you don't work well as a team, then you can't really build great software, right? Great quote here, no one can whistle a symphony, it takes a whole orchestra to play it, by H.E. Lecoq. Last but not least is one of my favorite quotes of all time, which is, always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Has nothing to do with the quote there, but you know, I had to say that. But also a tie that bind is the gratification after a little bit of depression. Sometimes when you're debugging something, you're like, I hate coding, I'm the worst at this. Why do I do it? But then you figure it out, and it's like the greatest thing in the world. So, you and I are going to play a game. You guys ready? Yeah. Sweet. The rules are, based on the project description that I give you, you get to guess on whether it's a tech or a music project. Does that make sense? All right, here we go. Let me hear you say tech. Let me hear you say music. All right, you're in. Here we go. First project, we had ambiguous requirements, required some agile development, continuous delivery, and tight deadlines. You can read the little descriptions there on each one to get a little bit more insight. Do you guys think it's tech or music? For tech guys, let me hear you say tech. Tech. If you think it's music, let me hear you say music. Music. You guys are cheating. That was everybody. It was actually, I made the theme song for the San Antonio Spurs this year, and it was the process that I used to actually do that. We had some tight deadlines. I had to understand the requirements from my client, and a lot of iteration, but continuous delivery, and we ended up happening. If you happen to be at a Spurs game, make sure you listen to that. Check that out. I am there with you in spirit. All right. Second, use some data insights, test-driven development, lots of third-party software, and a lot of midnight releases. What do you think? Tech? Music? You guys are cheating, I think. Saw my slides. This is actually my process for releasing music on streaming platforms. We actually do a lot of testing. There's a lot of tools for artists and creators now where you can figure out where your listeners are and actually target them with advertisements or new music and things like that. So I actually go through the same process I do in tech development as I do for releasing music as well. You ready for the next one? Had to gather some requirements, lots of user testing, really had to understand the science behind what we were doing, and then when we thought things were one way, we had to trust the data to actually tell the real story. So, tech? Music? All right, you guys are catching on here, man. It's actually the process to score a feature film. I had to work with the director to really understand what emotions we need to convey with music, but at the same time had to trust when, like, you know, we would test the scenes out and it would go a different way and we'd figure it out. So, sounds similar to tech, you guys think? All right, last but not least, a lot of late nights, even more foul language, a lot of drunken hook writing, and some really bad decisions. Tech? 100% of the people were like, me too. Yes. It's absolutely tech. This is actually my process for creating React software. Sweet. So I think there are a lot of ties that bind, you know, tech and music creation together. I actually spend a lot of my free time, if I'm not advocating for music education or, you know, writing music for some artist or TV and film, I try to figure out what makes these experiences the same. And at the end of the day, both fields of expertise require us to put in a lot of time and make a lot of mistakes to gain our experience. And experience is what you get paid for. So you make sure that if it takes you 30 minutes to do something that it took you 10 years to learn, you're getting paid for the 10 years and not the 30 minutes. Make sense? Cool. Make sure you guys follow me. I appreciate you. I love you guys. This has been awesome. Make sure you follow me, StatCash on GitHub, and The Real J Dash on everything else. I love you guys.
Hi, everyone. So let's just wait for slides. OK, so today we're going to, well, it's not on the start, the presentation. It's not the first slide. It's not the first slide. Sorry about that. Technical difficulties. I know Jay just killed it. And I'm going to make you some board presentation about components on your everyday UI tools. So we're going to explain what that weird word component is and how you have been already using it on the tools that you use and love. But please just bear with me on this kind of board presentation after the music one. So first, let me introduce myself. I'm Juan. I'm from a nice, lovely country in South America. We live on the Andes. We have the part of the Amazonian rainforest. We have the Galapagos Islands. And I've been using React and Haskell a couple years now. But before that, I fell in love with functional programming. So we're going to see what is functional programming exactly. So functional programming treats the computation as the evaluation of mathematical functions and avoids changing state and mutable data. Well, we have already seen some tools like Immutable.js or Redux, which try to tackle these parts, but these are already core values for functional programming. However, functional programming comes really tied with, wait for it, type systems. So I love that TypeScript is a success case for type system adoption, and there is something very worth of note. However, any sufficiently advanced type system will eventually lead to some weird words like monad, functor, applicative, commonad. And I'm a bit afraid that that might be turning people away from functional programming. Although there are tons of tutorials talking about how the monad is just like a burrito. So I'm not sure if that's true. I just launched something like that, but I'm not sure if that's actually true. But there is people out there trying to make these concepts more digestible for more people. There are initiatives like making functional programming more mainstream JavaScript. There's a project called Fantasyland, which I'm not sure if it's production ready, but you should totally check it out. It's mind-blowing, and you're going to learn a lot on that without ever leaving JavaScript. But this talk was actually inspired by a short paper named Declarative UIs Are the Future, and the Future is Commonadic by Phil Freeman, the author of the PureScript language, which is like writing Haskell for the front end if you want to torture yourself like that. So we're going to see what a declarative UI is, and I think you already know that for a declarative UI, you're going to have a render function, which is going to evaluate the state and will return for us a view. It's a very simplistic view of what React is, but React is a perfect example for a declarative UI, as many of other presenters have already explained that to you. We should also check the next concept. What is a comonad? It's not a simple monad. A comonad represents a lazy unfolding of all possible future states of a user interface, as well as the transition allowed between those states. And there you have the type class definition for a comonad in Haskell. Just because I wasn't sure about how to translate that to TypeScript, but I'm going to try to translate that. So you can think of a comonad here like an interface on steroids, which will have two functions that we're going to care about, extend and extract. Extract will simply take an object of type A out that wrapper, and extend will simply take a function that will modify whatever A object is there and make it a B. And we can see some patterns using a comonad, for example, and store. And the store here, this is simple JavaScript. It's going to take a state and a render function. You can see extract simply, it's going to evaluate the state and render it. And extend is going to apply that F function and build a compose store, modifying the store. And you might have heard this, but not really understand it. But there you have an example. There's the application store object. There you have a state, simple object, render, which will simply render for us some React component. And there we have something like using that store component pattern. So in extend, we're going to check if the message inside the state is word and change it for React Conf, and extract will simply render. So you have it there. React is a perfect example for a store component pattern. We still have more examples for what components are capable of doing. So let's just wait for it. I know that you might be familiar with this tool. We have Moore machines. So what are Moore machines? These are just finite state machines where the transitions are going to be restricted according to the type of the input I. And what I just say is something very similar to what Redux is doing. So it will restrict the change of state according to the type of the input, as you will see on our reducer, right? So there you have it. A Moore object where it's going to take a handle function and an application, and struct will simply take the application outside of that object, and extend is going to handle that update and move whatever is inside to a next state. And I'm not sure why the slides went back. Oh. But there you also have the definition for the Moore object. OK, so some slides are not quite correct. Well, you just missed the example with the Moore machines. But what you can take out of this is that you can combine these components and have a Moore object wrapping an application object, which is a store object. And then with those extract functions, you're going to start building it. Trust me, there are better ways to do this. But what's in there for me? I just heard this guy talking about co-monads, monads, burritos. What is he doing next? He's going to talk about tacos to explain React suspense? Well, just like translating the React documentation or making the web more accessible, I just want more people to join me into learning functional programming. Why is that important? Well, because your everyday monad is a burrito? Kinda. This just means that there's people that care enough to make tutorials for newcomers and make this more simple for everyone who is interested in joining us. And your everyday component is already in your tools. Kinda, because I'm not saying that React or Redux were actually built with these patterns in mind, but you can see that these abstractions are not an alien term, and you can actually apply it on your everyday life, and functional programming is worth to learn. So the takeaway I want you to have from this presentation, which just disappeared, is that, well, functional programming might be for many of you a new way of thinking. New ways of thinking mean new ways of solving problems, and new ways of solving problems means better software. And after all, isn't that what we all want? And that's it.
Lightning talks, am I right? Yeah. Once again, like preparing for a lightning talk is a lot harder than preparing for a full-length talk. You can't have any dramatic pauses. You got to really like applause and cheer and jeer for these folks backstage. They did a really great job on those lightning talks. Yes. Yes. Super excellent work. Super, 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 super duper. So are y'all all amped up on candy? Candy? Like candy. Yeah. Me too. I feel a little crazy, like a little bit of the jitters. That's fine. I'm going to use it on the stand-up paddleboard after the conference. Also, at the break is what it's called. That's when I'm going to be giving away the sloth mask. So be sure to let me know if you're the loudest guy in the audience or girl, or if you know the loudest human person in the audience, and I will give you the mask, and it's going to be awesome. I don't see a laptop up here. Is anyone speaking next, or is it just me? Just me. Well, here we go. Yes, okay. Okay. So, here's a funny thing. My friend gave me these tissues that look like $100 bills, and so I've been walking around wiping my nose with these $100 bills. They look like identical. Next break, I'll show you the $100 bill tissues. And so I've been walking around wiping my nose with $100 bills, and it's like I've been getting some like judgmental looks, and I just want you to know, like, I'm not that rich. It's just like a funny bit my friend made up for me. Also, what's the best candy in the jar out there? Because I think Sweet Tarts, Skittles, okay, Reese's Pieces. There's a lot of Reese's Pieces fans in the audience. Did you try the little Sweet Tart Chews, the little ball things? Woo! Exactly. Those are the most delicious things. Also, though, there are Sour Patch Kids minis. Yeah. Oh my gosh! Don't get me started. Look, I got a little guy, little blue. Yeah. Okay, so it looks like there's a laptop here now. Wow, the magic of technology. Okay, so next up is Luca. Luca's favorite candy is Twizzlers, which we also have in the jars up front. Twizzlers are delicious, and I hope that you enjoy his talk. Give it up for Luca.
Hello. Hi, everyone. Hi. We're going to talk about making games, animations, and interactions with the Wik editor. I am Luca Damasco. I'm a creative technologist, educator, and a digital tool maker. I love making things that help people make things. I love creating tools that people, especially beginners, can use to express themselves and have their own creative output. Right now, I work full-time on a project called the Wik Editor. It's a project I co-founded with my friend Zach Rispoli. It's a free and open source tool for making animations, games, and everything in between. We're a team of 2. We've been working on it for nearly 4 years now since we were students, and it's been awesome. And we'll talk about how we were able to get our tool to where it is today and what we've learned about kind of user experience since we started. And so I know you're all thinking, like, well, show us some animations. Like, what does this thing actually do? So here's one by Kate Shadoan called Good Eggs. It's about some good sentient eggs just waking up and trying to have a good time. Things get pretty wild. Like, I won't show the whole thing. If you want to check it out, go to Wik Editor. But it's an awesome animation by Kate. You can make games with Wik. So here's a game called Lockup Dungeon by Peter Sheehan. It's an 8-bit lock 'em up where you control a minotaur who's desperately trying to lock up his labyrinth so he can finally rest. You can control this character's movement with the keys. It has special attacks. It's a pretty fun little experience. Highly recommend to play through. Takes 3 minutes. Really great time. But it also makes these in-between projects. So we have projects like Click Me If You Can by Nick Diamond. It's not quite an animation. It's not quite a game. It's this like little interactive doohickey where you click this cat and he runs across a globe, and you kind of see him travel the world, get into like different situations and like all sorts of different types of trouble. It's a lot of fun. The cat runs into lots of problems, but it's a great little experience. And so these are some of kind of the more like polished projects and kind of more experienced projects people can make. But Wick editor projects can also look like this. This is Bunny Tunnels. It's by Lucia, who is 9 years old. She created this all by herself. It's a role-playing game where you control a bunny. You go through the tunnels, you collect carrots, and you avoid the tunnel monsters. Lucia created the first version of this game while we were running a workshop. And she learned during that workshop like how to use conditionals, events, keyboard-controlled movement, how to create multiple characters. For the first time ever, she had never made something before this. Look at that. That's incredible, right? Let's give it up for Lucia. This is awesome. She made a full game, and I mean, like, it's pretty sick. It even has an underwater level, like she went all out. Pretty fantastic. I'm going to share this recording with her, so she'll love those cheers. Thanks. And so we've known very early on that we wanted to design our tool for beginners like Lucia, but we didn't want to sacrifice any functionality for experienced people like Kate, Nick, and Peter, right? And as users like Lucia got more experienced, we didn't want any of the simplifications we made for her to kind of get in her way as she got better and better at using the tool. So how do we do this? Well, I haven't even showed you what Wick looks like yet. So this is Wick Editor. It's got a standard set of drawing and illustration tools. People can use these tools to make little characters, scenes, drawings on their canvases. And this is really where we want people to start, right? We know Wick Editor can make those complex projects I showed you, but we want to focus beginners on something that they can be confident in and not intimidated by. So some quick sketches, great place to do that. Now, you can turn those drawings into kind of more complex animations just by adding new frames on a timeline, drawing, and then eventually, in a few seconds, you're an animator. So this step is pretty key, getting someone from making nothing, like they've never made something before, to getting them in an animation in a few seconds. It's really exciting. It gets them confident. They want to keep making more stuff. And once they're ready, they've kind of experienced the tool a little bit. They can add interactivity to their projects by adding tiny code snippets to the things they make or the images they bring in. So they can add in like little pieces of JavaScript. This is some real JavaScript they can add. We have a little scaffolded coding system. And now there's a play button on this animation we just made in a few seconds. So yeah, so this kind of gets them in this mindset that they can start making and start creating and excited. The best part is it's all a web app. We want to take as many barriers to access as possible, take away as many of those barriers to access as possible. So we made it a browser-based application. There's no downloads or logins, and we wanted to increase the access for students that have things like Chromebooks, old school computers that haven't been updated ever, and tablets and stuff like that. It's made with React, which is why I'm talking to you guys today. And this is super cool. It's an incredible tool to work on, but it hasn't always been this polished. So let's talk about the evolution of the Wick editor over time. You guys ready to see an MVP? Yeah? So this is it. The slide changed, I promise. It's not there. That's the MVP. It's basically just a blank screen. We made it in under a week. We made it in response to a prompt by one of our professors to make a drawing program. And the way that our drawing program worked is you would drag images on. You'd have them on your canvas. You could add new frames or kind of move back and forth through your timeline, but with these little buttons, super intuitive. And you can add tiny scripts, like quote-unquote scripts, that would respond to mouse clicks when you clicked on objects. So clicking on this object will jump you to frame 2, and you can kind of make a little kind of hypercard-esque interaction there with what we have. So yeah, this MVP really taught us to go for the absolute minimum. This tiny little cruddy prototype was enough for us to start exploring the core loop of our app and moving stuff around on screen and creating these short interactive experiences that would build us up to making our full app later on. Yeah, if we had been focusing on too many details, we just never would have gotten anything done. I know that Zach and I got into like a lot of fights about like what needed to be in the final project for the end of the week, but this was a great little kind of step for us. And so we started wanting more out of the tool, and we created this pre-alpha version where we could test and create all new features, including really important ones, like a brush. We had an animation tool that didn't have a brush. This was coincidentally the first version where we actually started putting Wick Editor in front of kids and beginners, and we immediately realized that our notion of draw your assets in your favorite drawing program, like Photoshop or Krita or something like that, and then just drag them in, it wasn't enough. Like, you needed to have that fun, like, immediacy of making something on your canvas. And so here we learned to test early and often. Like, that first prototype was like fun for us, but it wasn't fun for anybody we were actually trying to make it for. And get all types of users to try our product. Like, we were getting some friends of ours to try our stuff, and we were getting some people that were other aspiring new media artists making things to actually like try out our tool. And they were like, yeah, this is great. I can work in Photoshop and make an animation. But don't fall into those convenient sampling tropes. You're just not going to get anywhere. It's kind of what we learned there. Next up, we kind of put together a little alpha version. We start pulling together pieces of the interface, and here we really start experimenting with different features for game development and interactive project development, like a new scripting system. It's based entirely on like event tabs. And at the same time, we're trying to create new, just like weird features that we think might be useful. Like this one isn't too crazy, but it's unfortunately the only one I got to work on the 3-year-old GitHub repo that I tried to like get screenshots for this presentation. It's a cropping tool where it was a first-class tool in the toolbar. You would take like screenshots of existing parts of the canvas and duplicate them immediately. It's like incredibly specific, but this was like at the time one of the most important tools to our experience. Like, it had to be on the toolbar. And I mean, it was a great kind of learning experience for us for what types of features we wanted to have. It taught us that it's okay to try out these weird features, especially the fact that they don't have to be perfect when we're actually getting them up there. We don't want to fall into a trap where we're just mimicking features from these other products that we love, like Flash, like HyperCard, like Scratch, just because we're too scared to try out something new. We need to be trying out those new kind of weird things to get anywhere. Yeah. And so then we moved on to our beta. This was with help from our first grant from the Frank Ratchey Fund for Art at the Frontier. We were able to create our beta version. We worked with some great designer friends of ours on this. There are so many elements of this version that come like directly from experience design sessions with those friends and testing directly with beginners who are using our tool for the first time. Things like the color palette even, like you might look at that and say like, oh, dark mode. Like, that's cool. But it actually came out of necessity because our old version wouldn't even show up on the laptops that we would go to schools to like try it out with. So we'd show up and this is what the kids would see and be like, so who wants to do like a paper animation lesson today, right? Like that's kind of where we started learning what we needed to do, accessibility-wise even. There are still quite a few problems, even though we loved this version. Every time we'd work with new students, there were aspects of our design that they couldn't wrap their heads around. So namely, so many of our features were hidden behind menus, drop-downs, right-clicks. Like, here's a right-click menu for just an image that I've brought in. Like, this is like all the functionality that we want these students to try, and they can never get here. We started to realize that this expert blindness, right, like the fact that we were used to so many of these elements in the professional programs we had been using, we were used to them, it was really starting to impact the ability for those beginners to actually use what we were making. And we had also been testing with a slightly biased sample of kids. Like, we'd hand them a mouse, and they'd know how to use it. Like, that doesn't happen very often, actually, to many surprise, like to our surprise especially. And as we expanded to new schools, we started to notice that less and less students were comfortable with these interaction methods that we had been taking for granted so often. And so we tried to take items out of these menus and put them into the interface itself. Like, here are some buttons we kind of just squeezed into the timeline, but this didn't work out. It led to a lot of visual overcrowding. And then we tried to add more buttons, and it would just get worse and worse over time. And so this just led to a whole series of problems. By this point, our small grant, as it was, had run out. We couldn't pay the designers to kind of help us anymore while we were making this and get some more feedback from them. So we learned very quickly that we needed to start designing for redesignability. We really needed to focus on the fact that we're a small team. We're working with very little resources. We needed to comfortably be able to change these elements quickly in response to the workshops and the testing sessions that we were running. It's really important important that we not only think of when we're making our initial designs, like what we'll be adding to the tool, but also what we're not sure we'll want to add. Like maybe we'll want to do something here, and trying to think much, much further than we even have a plan for of, well, what can we slip in here next time? If our design can only work with the settings we came in with, we're going to end up with a crazy crowded timeline like we had here. And there's no easy way to fix that when you're on a development deadline. And now, as another note on redesignability, up until this point, every version of our tool had been built using pure JavaScript, HTML, and CSS. We were building everything from scratch. This is not conducive to a quick and easy development approach, as you all know. And so this kind of led us to think of like what frameworks or tools could we use to actually improve our experience and improve the overall experience of our tool. And that landed us on React. There were so many reasons we kind of ended up with React. The incredible community of users, right? We could ask questions online and put up some issues, and we'd immediately get responses. It was fantastic. Extensive documentation made it really easy for us to learn. We didn't know how to use React like a year and a half, 2 years ago when we actually started this newest version of our tool, and we were able to just kind of pick it up almost immediately. The reusable components really made it much easier for us to hit those redesignability goals. Like we could break down all of the aspects of our app and pull in so much of the community resources around it. And certainly, not least of all, was React's decision to adopt the MIT license and fully open source the project. It made it super comfortable with for us to bring it into our project. Since we're an open source tool, it just kind of made sense, and we could plug everything together. And so this leads us to the version you guys saw in those animations before. And this is our newest version with our 1.0 release. With a grant from the Mozilla Open Source Support Program, we were really able to kind of like dig into what we were making. This version combines so many aspects of those original designs while trying to focus on that beginner introductory experience. Talking back to redesignability, take a look here. This is our Canvas Transforms widget. This is where we put stuff that like changes the way the canvas moves, like zoom, pan, being able to actually like control the drawing experience. Because we made it kind of extensible and thought, well, we might want to add new tools later, we're able to add things like onion skinning onto this bar and recenter in direct response to students not being able to find the onion skinning button in a workshop. So this was a real lifesaver for us as we continued through running these workshops and getting the feedback from our students. Next on, here's like a close-up of our timeline now. So you can kind of see there's like, that like little bits of expansive space that we can add new features to. We can pull things away from without destroying like the kind of interactive visual experience here. And we're also able to make conscious decisions like how much of that redesignability element is too much, right? Like we don't want the timeline to end up with 15 buttons like it did before, right? So consciously deciding like how much space, how much redesignability are we going to allow here was a part of these decisions. Yeah, and the entire tool also uses those great, community-based React components. Like React Reflex is what we use for draggable elements on our interface and the movable interface panels. And there's obviously some custom internal ones scattered throughout the tool to make it really easy for us to edit and update. Yeah, and so here, this version really taught us to leverage those community resources as much as we can. Like, gone are the days of us creating a custom tooltip and then like spending 9 hours being like, how do I get this to open on Firefox? Like, for the love of God. So like that's a big lifesaver here and a huge time saver. And so, yeah, I've been talking a lot about how we're doing workshops, we're doing testing sessions, but how do we actually like find these testers and figure out who's going to be the overall deciders on that feedback we're getting? First thing we did was we asked ourselves the question like, who are we building this for? What's the kind of main user base that we want to do this? We didn't need to know this 100%. Like experimenting with different groups was really important, but kind of answering this question allows us to focus that target group, which will eventually allow us to understand how to respond to their feedback more, right? So if we're getting input from professional new media artists, which we were at the time because we were in an awesome space where we could kind of run this by our friends, and that feedback is so useful, but it shouldn't go immediately over the feedback of Lucia, right, making her game. We want to make sure that there's a balance there and we understand how to respond to those pieces of feedback. So we ended up building a few simple user personas for our application. We had this complete beginner persona. It's someone that wants to get into animation and game dev, but they're not sure how, right? And I know I've got a picture of a little kid in there, but that goes across all age groups. Like who's that complete beginner to us? We have intermediate users who want to continue working in kind of their same methods, but the tools they've learned are either too simple now for them, they're too expensive, or they're too boring. And we also have students that are in schools, they're learning, and they want to learn about digital literacy, programming skills, just game development animation in general, right? So our initial testing group showed us like the potential in teaching with the tool, and that kind of led us to create this third kind of focused group of people we want to be building our project for. And so now where do we test? We got some ideas of who we want to test with, where do we actually figure out where to get these groups of people. And so our first thought immediately is schools, right? Like this just comes naturally, right? We have a bunch of kids there, they're all focused, this is gonna be great. And it was a good place to test, but there is a lot of regulation about getting, developers into a school and running a session with them, right? There's also like 45-minute class periods. You guys remember that? Like that's insane. That 45 minutes immediately turns into 30 minutes because people are walking in with their backpacks, throwing them down on the floor, taking time to set up, and like squeezing a lesson or a testing session into that time is very, very hard, and it changes room to room. Libraries immediately became another place we were able to actually create a community event. So it was easy for us to reach out and set up a free animation lesson and kind of get people to come in and work with what we were doing and get some feedback from them directly. We also had after-school programs, being one of our favorite environments to test in, especially when we worked with like the nonprofit after schools in our area. We could volunteer some time, we could run a session, a game design session, and we'd immediately have 10, 15 just excited young kind of creators that want to make something, they're not sure how, and immediately get their feedback from that. Game jams were great when we wanted to start moving into like the intermediate and advanced user space. We were able to kind of focus the tasks that we were going for, so we could be like, this is going to be a game jam centered around point-and-click adventure games, or this one's going to be centered around, physics-based games, right? Like figure out what you can actually build with the tool. And this was great. Again, leaned us towards the experience side, so we had to constantly be thinking about the feedback we were getting. And lastly, since I'm an educator, integrating this tool into some beginner courses at the university level that I was teaching allowed us to generate some feedback from less experienced developers in older age groups. So those complete beginners that hadn't been doing anything yet, but they had more kind of like initial technical skill, whether that be artistic or just, they know how to use a computer a little bit better. So yeah. We picked our locations. Now we really want to start understanding the bias in some of the choices that we're making here with who we're testing. Bias in each of these choices, where we test, who we test with, is real. But you have to acknowledge and account for it where you can, right? We're actively trying to consider as many aspects of this as possible. For instance, if we're working with an affluent school or school district, they're going to have a completely different set of experiences, hardware, and skills to a school that hasn't had that laptop upgrade in 10 years like I'm talking about. So it's super important that we test it with a wide range from all walks of life, and we kind of adjusted for their feedback accordingly based on those, extra situations that we had no control over. And so testing strategies. We figured out where to go. We know who we want to test with. What are the strategies that work best for us? And we've kind of developed over time. Every single session we ran, whether it was a workshop or official testing session, had a big rule that kind of supersedes all the tips that I'm going to tell you. And that's that kids aren't test subjects. Throughout our entire time testing Wikeditor, every single session we've run with the students has been a learning experience both for them and for us, right? With them as the primary learners in this spot. The primary goal of the session is always their enjoyment and kind of what they're going to take away from it. With those goals in mind, every other element we learned came naturally. Like if we were focusing on the students' enjoyment and the kind of their overall learning, we immediately got better feedback. And this worked wonderfully for our team's motivation too. Like we knew when we left the session, if the kids were smiling and they were like ripping their laptops up saying, look at what I made, look at what I made, we knew we had hit it that day. We knew that we had solved either the teaching element of working with a bunch of students and kind of teaching them a piece, or an interface element, or some other functionality of our tool. Yeah. And so we structured each session with a lesson plan. We create learning objectives for the students where they could either, some combination of creating, just learning how to make something in general, like we're going to make an animation or a game today. We let them explore, so we teach them about topics that were outside of our tool itself. So maybe we give them a little history of game development or a history of animation over time, just to kind of spark their interest and get them excited about what they were working with that day. We'd give students some insight and access to what we were doing as developers and demystify kind of the concept of like, what does it mean to actually make this tool? We'd make them part of that experience and make it really clear, the feedback you're giving us, we're going to come back and write some code, and it's going to update this tool. So next time you see when you log in and you see the version number change, that's your feedback going in, right? Letting them know like how that process works. And this all worked wonderfully to kind of get them excited about working with us. And so now what do we actually do? So what are the main tips after that kind of like setup to get a great experience? First piece is set ground rules. So we'd always start by setting a baseline for every tester in the room, every student in the room, and making it clear what was going on that day. So like, I'm Luca, I make this tool. Great thing to start so that they're not like, who is this guy, like up in the front of the room. We tell them what we'd be doing. So like, we're making animations today, and depending on how many oohs and ahs, we'd know how much of like I promise it's cool, you're gonna enjoy this, we'd have to do to kind of like get them into it. And then we'd give them permission to just like tear our tool apart, like immediately. So if we don't tell them this, we're gonna get like really polite responses. We'd always get this like really, oh, it's good, I like it, right? It's not gonna give us anything to work with. But you might find one firecracker, like if you don't give them this, like a student that will be like, the brush sucks, like what is this? Like, I can't do anything. But for the most part, they're just not gonna say anything that's feedback you can work with. So let them know that they can just tell you every problem they have. Give specific tasks. So we're always trying to give our students as specific tasks as possible without ruining kind of the exploration experience they have. So something like make 3 frames of animation gives them an opportunity to like stay within the rounds of the drawing tools, stay within kind of a realm that we understand, right? We have a reference for how this should work, but it gives them an opportunity to explore. And it makes it easy for us to spot when a user is doing something abnormal that we'll need to correct for later, right? But a task like make anything you want, this is fun, right? But then we have 25 people in a room doing something completely different. It's very hard to parse through that feedback and actually break that down in a way that we can manage, reflect on, and improve our project upon. Next up, we've kind of come to learn to experience those limitations in full, especially with working with schools. We'd run into so many hardware and technical problems that you wouldn't think of while developing on your beautiful dev machine. Like there's so many things you wouldn't expect. Like you come into a class and you're like, oh, I'm a browser-based tool, I'm expecting this, and then you'd immediately see that and you'd be like, oh my God, what am I gonna do? And sometimes we'd have to pull out the stack of paper and be like, you guys ever break a flip book before, right? But allowing these kind of limitations to hit us and then trying to correct for them right after allowed us to kind of improve our tool and improve the experience around both the sessions we were running and the tool itself. Don't try to fix the space. If you fix the space, we would kind of ruin our results for that day. We'd walk into a classroom, we know they have Chromebooks, we'd bring a bag of computer mice with us in case anybody wanted to use the computer mouse. And that might improve that one session, but it would lead us to problems like the giant right-click menu because we'd be focusing on those students that had that extra output with their mouse. But sitting down with a student and trying to explain, well, if you put 2 fingers on the trackpad and then you click down on it, it's going to pop up this little window. It starts to let you realize how ridiculous that concept is to a student that's never used that before and makes you actually kind of consider the design elements of your entire experience. Watch and learn. So this is one of the harder ones for me, especially. I've gotten better over time, I promise. There's going to be hundreds of times you see a beginner user struggling and think, if they just hit that button, I know it's going to do what they want. But don't touch anything. Just let them fail, right? you're going to walk up behind a kid, and they're going to have the eraser out, and they're going to be like desperately trying to get each piece of the canvas away with the eraser, and the eraser's this small, and you're like, oh, if they the cursor is right there. If they just select it and delete, just let it happen. Let it happen. If this eraser press, and this has happened so many times. The eraser press just keeps going. They're on like a machine from 2011. It runs, and then this is a video. This is like still going, right? So, and it just like freezes up. Let that happen so that you can correct for it and improve upon it later. It's these unspoken moments that really need to be considered, written down, and kind of revisited after the fact. And then you can help them. Don't just like leave them in the dust, like be like, oh, you lost your project. Sorry, kid. Then you can help them after you run into this, and hopefully autosave worked. So allow for exploration. So now I said that prompts that are too open-ended have led to issues, but we to try to leave the time at the end for students to just kind of explore. Curious students are going to find extra things in their free time that we wouldn't have planned for in our lesson. Like a lot of times we'll find critical optimization problems that we didn't hit in like the plan that we had set for them that day that they were going to walk through. We might find parts of the tool they wanted to experience during that lesson plan or during that workshop that we didn't think were as important. It's like a kid from the back of the room being like, how do I add sounds? Like 6 minutes into your animation workshop, you're like, well, we were going to do that maybe tomorrow. Like, I don't know. Like, it lets you really rethink what's important to them versus what's important to you. Yeah. And so now, get a response. So I've been talking about, that one kid in the back that might scream at you if they're running into a problem. But if you're working with younger students, it's like for us, it was so hard to get actual responses out of them as we were working. Like I said, they might say things like, I liked it and it's good, but this isn't helpful at all. So I'll go over to those more quiet students and be like, what was the worst part about making your animation today? Or what was the best part about, making your game today? And that'll start the floodgates of like the good and bad feedback that you can then poke forward on, right? Like if I'm working with a middle schooler and they're like, it was really hard to add that first piece of code, I know I can keep asking questions about like, oh, well, walk me through what you did. What did you actually, insert here? What did you add here? And that'll kind of let us reflect on that feedback after. And kind of the last major tip I have here is learn how to interpret the feedback. So someone saying, I had a problem adding code is like a nice, like easy pathway into asking some more questions. But younger students, they don't know how to formulate like an actual like response to some of this stuff. So you might have a student like look up at you and they've been jamming away, they've been scribbling, they're killing it, right? And she'll look up at you and say, do you have any purple? All right. And after responding, we have all of the purples. And then watching that 5-year-old's face like light up like a Christmas tree, right? Don't just ignore this comment. Take that, write it down. This comment actually means that something in either my teaching approach or in the interface led to a problem for them. It made it too hard for them to actually find the color picker. It made it too hard for them to actually change their color, right? But yeah. In the end, after all this testing, reviewing, and teaching, make sure you kind of reflect, if you're making a creative tool, especially on like what people were able to accomplish, what those students were able to accomplish that day. We take a quick cursory search at YouTube and see kind of what we could find tagged with Wikeditor and know they were so happy about what they made, they put Wikeditor in their description. Like that's a good piece of feedback for us. And we can be confident that we've given them a product that they can be proud of and kind of excited to use. So yeah, that's my talk. Check out wikeditor.com. We'd love to see what you make. Thank you all for listening.
Yes. Champion. I'm a champion. Everyone's a champion. Where are you guys going? What is happening right now? Did I not get a memo? Where are you all going? You better sit back down. At the next break, which is like literally in 30 minutes, you couldn't wait 30 minutes, so class act. Okay, so in 30 minutes, it's because you heard that somebody won the sloth mask, isn't it? And you're all giving up on the conference. Okay, at the next break, we're going to have some snacks. Those snacks include a crudité, pita points, and trail mix. It's not good stuff. But there's 90 pounds of candy to satiate your tummy in case you don't agree with boring food like that. Some delicious crisp vegetables and a roasted red pepper hummus. Whoa! Yeah. Next up is somebody you probably all know, Jed Watson. He's going to talk about React Select. Who in the audience uses React Select? I think that there's probably more of you, and you just don't know what you're using. Yeah. Okay, true little story. I work for this tiny little company none of you have ever probably heard of. And at that company, I, like a year and a half ago or 2 years ago, we were having this problem. There was a form. We have a React Select in the form, and then you would select something, and then it would load data. You understand? It's a very common thing. And then something else would populate in the form. And people were very confused about the workflow and why the button wasn't enabled yet and why the data would change suddenly. And so, like, the React Select has, default additions where you can add a little loader. And I spent, 72 seconds adding the loader because it was, a default configuration for the React Select. And people clapped for me. Like dozens of people that I worked for clapped because of this tiny little loader. And I never told anyone it was because it was easy. I just was like, yeah, that was so hard. I worked really hard on that. Anyway, so I owe Jed Watson a spot bonus. And you probably all do too. Remember, like, if you're rich, or you work for a big corporation that is rich, you can always give money to these open source projects that you use every day, because it takes money to build open source projects. And if you really appreciate them, you should give them your money. Do you understand? Capitalism. Yeah. So don't forget to give people money. Thank you for coming to my TED Talk. Okay, give it up for Jed. He's my friend and yours.
What's up, React Conf? Hi, everyone. This is really cool. I'm so stoked to be here. 5 years since I came to my first React Conf, and this is my first time seeing it from this side. Honestly, I could not be more excited to share this story with you. So thanks for the intro, Devin. I'm Jed. You might know me from the internet as Jed Watson. And I work for, or actually co-founded, a consultancy in Sydney called ThinkMill. At ThinkMill, we make software, but this story isn't about that. This story is about something that I made called React Select. Now, it was actually almost 5 years ago to the day that I published the first version of React Select to NPM. I had no idea what I was in for. I starred it myself. That was really cute. That's that 1 star there. And over the next year, it matured. I added a lot of stuff to it. I got 1.0 beta out. That's okay. React was still on a 0. Release at this point, so it was very cool to be in beta. Started picking up some stars. Another year, RC, because what comes after beta, the RC. Stars went up. That was pretty crazy. And then another year after that, 1.0 was released. And everything's kind of tracking along nicely, but you'll hear more about that in a minute. I just want to give you the timeline of the whole project. So a year later, we actually released version 2, which was a huge rewrite. And this is where I've started tracking downloads. And as at today, this got big. Wow. That's a scary amount of downloads per week, honestly. Also, this is a really long time. This is 5 years of my life in like one component. I've changed a lot in the last 5 years. It's also changed a lot in the last 5 years. Anyway, this is a story that I wanted to come here and tell you today. So it's a story about a Select component and my experience as an open source maintainer and how that worked out. So there was a really great talk earlier today, and this one line stuck with me. I created a terrible first draft. And I was like, yeah, I sure did. And then another, and then another. But it is kind of a masterpiece. And just to put that in context, like, I don't know how this happened. React DOM gets 5.5 million downloads a week. That makes sense to me. Class name still gets a lot. Redux and React Router, I'm like, yeah, they're huge. But React Select actually gets 30% of the downloads of React DOM, which means that for every person or every like 3 people using React on the web, or I guess if you're counting by downloads, someone's using React Select. Why? It's crazy, right? It's just a select component. So it's actually got quite a lot of features. I set out from the start to build a whole lot of stuff because I needed them for a couple of projects I was working on. There are things like search as you type, single and multi-select focus management, menu layering and positioning, being able to pull in menu items asynchronously from an API, also a huge focus on accessibility and touch support, keyboard, and being able to create new items if they didn't exist. And it wasn't just about the features. I had some design goals for the project as well that I think might have helped it in the early days. So the design goals that I had were that it had to be powerful. I wanted to make a proper declarative React API for it. I didn't want it to be too opinionated. I had this idea like you should just be able to use it in all these different scenarios, and just because you're using it, like if people are putting this in their apps, then they need to be able to own the data. They need to own the way it's working. They need to be able to control it. It should also perform really well. And finally, like, despite the power and the flexibility, I want it to just work. Like, out of the box, right? You install this thing from NPM, you put it on the page, and it just works. Big goal. So I got to it. And I've got to say, React made it really, really hard. There's all this crazy imperative logic that you need to abstract, like focus management. You click on the control, and the focus needs to move to an input, but the control's already focused. Like, it really bent my head for about a week, actually, the first time. Debouncing updates, but it was like a deep dive into the life cycle of React, and eventually React was right, and I learned, and it started working. I got it to work, and it was like this, wow, I know how to do this now. It was amazing. So that was really quite a cool experience building it for the first time. I used, for the nostalgic amongst you in the audience, React 0.12, underscore class names less gulp and browserify. This was my toolchain of choice, just to age myself. But I put it on the internet, and it was a blast. By the time I was done, I had about 50 props, all this internal state, intricate logic. I was really proud of it. It worked. And I learned about the first phase of open source, which is joy, excitement, and stars. It's really exciting. You put something out there, people like it, they start using it, you get happy. You feel like this. Also, side effect of publishing stuff on open source is that people open issues and PRs, so you actually get to learn a lot. You get to integrate a lot of new knowledge into your project. And I did that. I also made some really good friends along the way. So early contributors, people like Brian reached out and started helping me. And it's been really good. Quite a few of the people who worked with me on this project are friends, like some of them are in the room today. But honestly, things got a bit out of hand. And all that intricate logic that I mentioned, yeah, that led to a lot of core complexity. And, you know, this is kind of understandable for a first draft. Whoa, that's too many slides. All right, so now React is meant to be really good at this. As things become complex, you can break them down into components and compose them back together again. React's really good at helping you with this. In fact, there's a whole page about it called Thinking React. Now, this is my favorite page on the React docs. Now, this is like, if you could read one page on those docs, sorry, Dan, it would be this one for me. And it's got this great diagram of how to think about breaking up a UI into smaller components. But what if you can't actually break down a component any further? All right? The challenge with a select is that they're really complex and sophisticated, but you can't actually break them down into any smaller primitive. The way they manage options and values, they sort of behave like a single input. And the way they manage focus and accessibility, like, it's all kind of got to be tangled together. They need to be controlled by a single brain. And you can probably see where I'm going with this. Because every new use case required more complexity to be added into the core component. And the thing is, like, everyone who has a different use case for a component like this only really needs to customize about 5%. But every person needs to customize a different 5%. So your surface area of like what can be customized becomes a significant amount of the component. And because of that, issues and PRs mounted, edge cases coming in conflicted with other edge cases, and also life happens. This is my favorite slide. This is me, my wife, and our daughter. Thank you. This is a really happy slide for me. Honestly, like if I could get away with it, the rest of my talk would just be photos of my daughter, right? Because like that's all I want to think about, and that is what happened to React Select. This is kind of where the wheels fell off, right? Between the complexity of maintaining it and trying to integrate all these different use cases and fix bugs, and just having less time. Ooh. You know, I had a life and a job and a new child, and React Select was actually none of those. And it suffered for it. And so I learned about the second phase of open source, which is maintainer's anxiety and loss of sleep, having hundreds of open issues and PRs, and a lot of community frustration, because on the other side of each of those issues and PRs is a human who's put their time into either using your software or contributing to it. And you're not talking to them, you're just ignoring them, and that feels terrible. It really does. But I had a lot of time to kind of reflect on this and learn from what went wrong. And the way that I'd set up the project, it was hard for anyone else to step up and understand and maintain the complexity that existed. And also just like the way I architected the component. I spent a lot of time thinking about the way I'd architected the component. And I started realizing that actually, the only way out is through. I have to architect myself out of this mess. And so I really wanted to do that. And luckily, about this time, ThinkMill started working with Atlassian on AtlasKit, which is their React design system. And if you've ever used Atlassian software like Jira, you'll know it's got a lot of selects. Like Jira is basically a glorified form interface, right? Full of selects, that's all it does. They have components for assigning users and filtering issues and changing statuses and selecting options and inserting emojis, and some are async and some are fixed, and like everything you can think of. Everything that moderately looks like a select, AtlasKit needed to build. So I was like, cool, how are we going to do this? And I had a look at the way that they'd done the selects in AtlasKit by the time I sort of got involved and started working with them. And they had two. There was a single select and a multi-select that had stateless and stateful variants. And the problem with this was I looked at that and I was like, wow, these are just as complicated as mine is. And they've got all these features, but they've actually got more yet to implement than they already have implemented. They're already this complex. Like, this doesn't scale. Not at all. But also I looked at the list of things to be done, and React Select had already implemented most of them. So I had some prior art to draw on. And we started thinking, wouldn't it be cool if we could figure out how to create a new select built on the maturity of a 2.5-year-old open source project that actually could scale and do everything that you needed to do. Or in other words, we started thinking not so much about how to build a component as how to build a framework inside a component. So that version 2 rewrite that I mentioned that came in about halfway through the lifetime of the project, this was it. And what I did, instead of looking at other components and other React code to figure out how to address this, I looked at other significantly successful open source projects. I took inspiration from things like ESLint or Babel, which set themselves up as frameworks and then offload all the complexity of the different use cases into userland. You've got all of these plugins that just hook into the core APIs, and I thought, how could you apply that principle to a component? Because those projects, they're sustainable. They get maintained. That works really well for them. Can I do this? How do we do that in a React component? So I spent some time thinking about things that make up a component and got down to 3. There's state, and there's functionality, and there's the user interface, which is the view and the styles that result from that. How do we change that? Well, we got one thing, props. That's our tool. How do we use React's props API to control these things and make them flexible? Let's start by having a look at state and functionality. What we can do is we can break these down into smaller independent parts and use this props API to allow them to be controlled by other components. Let's have a look at things you can do with props. Fundamentally, I think there are kind of 4 major categories. There are state or switches. There are events or callbacks that get fired by the component when that state should be updated. You can do extensions or functionality by passing functions into props, and of course there are children or render functions. So using these, let's see how we can simplify the component. Starting with state this time. React Select has 4 discrete buckets of state. This is much more obvious these days with hooks, but when I really looked at what was in my bucket of state, it was these 4 things. You've got the options for the menu, the current value of the component, the current value of the input inside the component, and finally whether or not the menu is open. So we kind of broke those down into 4 distinct things and made them controlled. Now, to that second type of prop, because these things need to change, we need some events. Let's add them in. Now we're expecting the state to be provided and just calling out to the event when they should change. And this simplified the core of the component considerably, because no longer did we have all this branching logic for controlled or uncontrolled within the component. Also, now my component can be smart or dumb in different ways. You can mix and match this stuff together. This is great, but I'm sure you can see the problem. If React Select isn't managing the state, that means the user has to now. And that broke the design goal of it just works. Enter the higher order component pattern. So I'm sure you've all seen this or used higher order components at this point, but this was actually a breakthrough in how to extrapolate sort of complexity out of the core component into other components. I'll show you a simple example of how this works, just to manage that value and on-change prop. So breaking this down, we have a new component that accepts value and on-change. We then track some internal state. We determine whether we want to be paying attention to the prop if it's provided or the internal state value. We create our own on-change, which is like a transparent kind of pass-through method, which will update the internal state but also call out to the prop if it was provided. And then we put those onto the component, spreading the rest of the props through. So we have this transparent state controller now that we can wrap around our select component. And to export it from the package and get back to it just works, it's as simple as this. We import the select and the manage state, and we wrap it, and we're done. That's a pretty simple thing to do. Let me show you how it gets more interesting. The asynchronous version originally was like a lot of the complexity of the core component, and we use the same pattern to do this as well. So get options returns a promise. We have some state. This time we're handling the on input change, and we're spreading it all into the select. So this pattern is really powerful. And in terms of exporting it, it looks like this. That async component can be simple because it knows that it's going to get wrapped in something that's going to manage its state for it. And now we're good. Now let's look at another third category of things you can control with props, which are extensions and functionality. So we consolidated a lot of learnings from version 1 and really focused on how to use props in a way that made the component more powerful and consistent. Remember that goal, unopinionated? And like respect the sort of user, the sovereignty of the data that people are passing you through. I'll show you what that means. You have a select component, and it gets passed in options. It passes the same value to the on-change, untouched. Select doesn't actually need to know anything about that, because you can customize how the options are filtered, the way that they're selected. Right? We have same defaults, but we kind of allow the user to change as much or as little as they need to about that. I'll show you an example. If I've got these options, myself and Brian, and I wanted to use, instead of a label, a first name and a last name property. All I need to do is add a getOption label method to that to concatenate them together, and we're done. Or let's look at filtering. React Select has quite a powerful filtering library built into it. You can create variations on that and pass it in, but to get that to work with this new example, I just need to take the candidate and the input and like write my own function, and I'm done. So I've replaced as much of that API surface area as I needed to, but nothing that I didn't. Now, the final piece of the puzzle, if we're really empowering the user, is telling them more information about how stuff's changing. Declarative is quite limiting in the sense that we can't say, we can just say this is how it is, but we also need to provide information on why. So going back and having a look at events again in the context of supporting extensions, originally we just had this onChange, which would send you a value. We added meta into that to say why it changed. And that's also really powerful for extension authors, because you now know, oh, this value was changed because the user added an option or removed an option or cleared the control, all that sort of thing. So that's the state and functionality out of the way. We'll just remove those values from our select. And let's have a look at things that make up a component. Again, circling back to the start, so the last piece is user interface. Now this is the thing that I'm most excited about. So one of the things I've always loved about React is this pitch. View is a function of state. This is really simple to get your head around, but I'm going to extend on it a little bit and say that it's not just the view, but also the styles are the function of state, because those two things together make up what you're seeing on the screen. And so shout out to Emotion and CSS and JS for really making this a reality in React Select. This is incredibly powerful if you're trying to build something that's extensible. So remember how I said a select is a really scary big component? It's still made up of identifiable UI components. And they look like this. You've got the container, the value label, a space for a loading indicator, a separator, a drop-down, a menu, a bunch of them. So we came up with an overrides pattern that lets you customize all of these. And what you can do is you can specify your own component or your own style function to apply to each of these different components that the select wants to render. And they're both the style function and the view component are provided the same state by the select itself. This is really powerful. So we'll take this example of myself and Brian again. And let's say that we wanted to take that value and link out from that value component to our Twitter. We can do that. We create a custom value component. We render that link. We pass the value component into the select. And hey presto, we're now links. And people can do this without changing the core anymore. Let's get a little bit crazy. Let's use a styling API and add a color in to each of us. So now we can create a value styles function. Again, it takes the same state, which for a value is the one that it's representing. We can change the background color, pass it through to React Select, and now we can be themed. And this sort of thing was never possible in version 1. This is actually a huge advance. But we can put it all together and do even more powerful things. I had this crazy idea. I was like, how far can I really take this? What if I do something just ridiculous? What if I try and create a date picker? Because that's the other category of really complex component in React. And what if I accidentally solved that as well? I did. It works. It's so crazy it works. This is the default set of options that are provided to the component. I hooked up the onInput change to a natural date language parser to pick a date. So when you start typing in next Monday, it actually picks next Monday for you. Or if you type in something like the 25th of August, it will go straight to the next 25th of August. And this is just like in userland. This is an example on the React Select website in about 100 lines. What's going on here is we're listening to that onInput change just like with an async select, but then we're running that through our natural language parser. We're picking the date we think it is, and we're generating dynamic options rather than loading them from a server. We're using a group to create this calendar type thing, and then we're using our custom styling API to make any of the dates inside of a group render like a calendar, and we're indenting the first one by the number of days. And that's all just using the APIs that I've shown you. Yeah, it's cool. So, like, this happened, and I knew I was onto something, because for very little effort, we got all of the same accessibility, keyboard touch support of our core select component, like, for free, out of the box. It's maybe not the best date picker in the world, but it's actually a really good one. And what I realized at the end of all this was, coming back to thinking in React, components aren't just for UI. They're for state and functionality as well. And it turns out we actually can break down a select into smaller components. And with this new customization API, most of these use cases didn't require changes to core anymore. And with that, I found the third phase of open source, which is, mostly sustainable. It's better. It's not It's not perfect, but man, it's so much better. So this made a lot of difference. Anyway, some takeaways for you. The things that I learned through this journey. So some for React architecture. React's composition model for me has always been its secret weapon. This is why I got so kind of attracted to using it in the first place. Like being able to turn things into components and compose them in a hierarchy, like that's it. Everything else is just making that work. The reason why is it allows you to let complexity in and then break things down, compose them back together again, and repeat. And the secret to doing that successfully is paying attention to which component owns the state and just designing good props with that in mind. All of the bad things I've seen happen in React applications is when people haven't thought about which component should own the state or how that should be able to be controlled. I want to say it's that simple, but it's not. It's actually really hard, but it kind of ends up being that simple once you get your head around it. For any of those of you who work on design systems in the audience, this actually ended up being really influential on AtlasKit and other design systems that we build at ThinkMill. The whole pattern led to multiple different components composed on top of lower level primitive components. And when I say primitive, I don't really mean like simple. Obviously, the core select is not simple, but that composition pattern actually, you think about the ones you finally export as the artifacts of your design system, everything under that is part of the framework of your design system. And that helps them scale and be a lot more sustainable. A good way to think about how much to lean in on this that I've been sort of thinking about lately is this: where is the complexity? You can think of a bit of a spectrum of complexity from, is the complexity in the styles? Is it all there, like a button? There's 50 different ways of rendering it, but it doesn't have to do much. Or is it like a select, where really it's halfway in the middle, and then you're probably going to get real benefit out of thinking about that component as a framework. Or even something like a tooltip, where most of the complexity is just in positioning and rendering and timing and debouncing and things like that. Also for design systems, I just want to bring this slide back up again because I can't emphasize how much of a game changer this was, moving away from static style sheets where we had to predetermine the state to being able to use state dynamically. I know there's a lot of trade-offs and cost sort of benefit that you can look into in terms of how you're going to do CSS and JS or versus static. Also choose your own library. But this was a real game changer for this kind of component. And final set of takeaways is for anyone involved in open source. As hopefully this helps explain, composition is king. People will find use cases that you have never imagined. That's the fun. Well, some of the fun. But how do you design an API that makes that possible? Once you've got that API, automate everything, or even beforehand, automate everything. This lets you maximize the time spent actually considering those issues and PRs and not the manual process. We came up with a whole lot of things for React Select, including a lot that we built ourselves to make it sustainable. We have Prettier and ESLint for code styles. We have this great tool I want to give a shout out to called Change Sets, which manages all of the changelog generation and release process. We have automated website deployment to Netlify and branch preview deploy, so when a PR comes in, I can actually test it and see it and play with it while I'm looking at the PR without cloning that branch locally. All of the examples have a button that will let you launch them in Code Sandbox automatically, which is great for getting people to submit issues with reproduction cases. We generate all of our documentation automatically from our types. There was a talk yesterday that demonstrated a similar thing, but we did that as well. And I would never have been able to document the surface area of this component without a tool like that and keep it in sync. And finally, tools like Cypress for automated testing are also invaluable. And the last one for any maintainers is to empower other maintainers. Getting other people to help me with this has been the best thing ever. I want to give shout-outs to Josh Mackison, Dave Brotherstone, Brian Vaughan, Charles Lee, Mitchell Hamilton, and the AtlasKit team for helping me with this, because without them, I would not have been able to do it. Find anyone, friends, family, pets. Maintainers are just your best friends in open source. As a little bonus for anyone who is using open source now, the other side of this whole puzzle, let me just share a couple of things with you from my perspective that I've learned over the years. The first one is stuff like this is really not actually as helpful as you think it is. No, let's not do this. Instead, this tells me nothing. Right? I've got this super complex component, and I'm trying to figure out how to incorporate some idea that you've got that you think you need into my abstract problem-solving brain. I don't want to know that you need something the way it's written or the way you think you need it. I just need to know what you're trying to do, because then maybe I'll understand that you need it, or maybe I'll realize that you need something else. So I'm trying to do X, and this would help me because Y is really the information that makes it so much easier to maintain these projects. Or even better, sometimes I get this one and I love it. Is there any way I can help? All right? Yeah. Thank you. If someone's not responding to you on GitHub, it doesn't mean they're not listening. It might just mean that they're actually really struggling to find the time to answer it in the format that it's been posed. That's a real thing. This was asked of me on Twitter just last week. Is it okay for someone new contributing to an open source project to comment or review a PR? And yeah, absolutely. That's actually really helpful, as long as it doesn't look like this. This is me. I did this. It just looks good, and submit review. Mitchell, you're a star. Thank you. Yeah, same thing, right? It's not actually helping me as a maintainer understand the code review that you've done. Tell me what edge cases you found. Tell me why the change is safe. Help me understand it without spending the time sinking into the code myself as deeply without any context. That's a super useful thing as well. And finally, just be nice to each other. I've had so many people get angry with me on GitHub that I've never met. I've had people treat me like shit. It's really weird. I'm nice. I try and be nice. Just be nice to each other. And as an open source maintainer, I've had issues come up that just deeply upset me. And instead of spending the next 2 hours that evening answering issues and reviewing PRs, I'm just kind of fuming inside. I'm upset and I can't get myself back out of that headspace. And I go to bed upset and you know what? It didn't do anyone any good. I didn't ship any code. Sorry, that was a bit of a rant, but you know, so important. Let's be nice to each other. Anyway, are we done? Nah, of course not. There's heaps left to do on React Select from here. Working on a hooks rewrite to prepare for concurrent mode. I'm really interested to see how these composition patterns that I showed you evolve once we get to hooks and concurrency. I think they'll change a little bit. I'm not sure how much. I think they'll simplify the logic a bit more, but it's going to be really interesting to see how that evolves. I'm hoping that being able to bring those benefits that the React team's been talking about with hooks to the project will also help make it friendlier for other contributors to come in, because it does make the chunks of logic and code it's dealing with clearer. So you're welcome to contribute if you want to help. If anyone wants to shout out and help me with this, come and have a chat or reach me on Twitter. That'd be great. And final shout out, we are actually working on a design system framework at ThinkMill that's trying to take these principles to a broader set of UI components. And if anyone's working in a similar space, I'd love to talk to you about that as well afterwards. Get in touch with me. And that's it from me. Thank you.
Great. Wasn't that awesome? I fucking love React Select. It's good. Okay, it's time for a break. Enjoy your pita squares, triangles, tips. If you're a speaker, please hold back and come up here. Once again, sorry about it. Anyway, see you later. 4 o'clock, we're getting back. I like this background. It's cool. It's like the 80s in New York City. That's the emotion I am reminded of. Okay, so I have to tell you something. A lot of people have come up to me and told me about how wrong I was about the PETA points. I hear you loud and clear. Thank you for the check. I will be better in the future. The PETA points are fine. But I just want you to know, like, they're not as good as chicken tenders. Right? Or, I mean, have you ever had pizza? Even the worst pizza I've ever had is better than those PETA points, which are fine, but even the worst pizza is better than them. That's all I'm saying, like Totino's or whatever. Oh, great. A Tombstone. You know, like the $4 pizza that you get in like the frozen aisle at Safeway, or like 3 for $10, like the real terrible stuff. A cafeteria pizza from elementary school with like, is that cheese? I don't know. Better than those PETA points. But they were fine. Stop heckling me. I don't deserve this. It's the end of the day. Work so hard. Okay, here's the deal. Anyone that's left at the end of the day, at I think it's 5 o'clock, we are going to take a breakfast of champions photo of everyone that's remaining at the conference up here with the best background that we're saving for last, because all of the bailers don't get to see it because they're boring and lame having naps in their fancy robes in their rooms right now. I'm going to have a night nap later tonight when it is nighttime. Night naps. Listen, repeat it back, folks. Night naps. Night naps. Yeah, living for a night nap. Okay, so that's when we're saving our nap time. You and me, everyone together, HGTV, synchronized in our rooms separately, night naps. Okay, so let's get started. You guys, you all stoked? Yes. Yeah. I just want you to know, I appreciate the cheers, but the sloth mask has been won by Ashley. Ashley. There he is. A gentleman and a scholar. He won it fair and square. Follow him on Twitter. He's smarter than I am, too. It's not very hard, but he's winning. Oh, looks so good. You look so good. Yeah. Those of you on the live feed, there's an actual sloth in the room. You missed it. Sorry you didn't win the lottery. Oh, okay. Up next is Lizzie. She is so cool and so smart, and her favorite candy is Twix because she understands that they're better than Kit Kats. But she also just told me she really enjoys tie-dye. What a lost art. Everyone give it up for Lizzie.
Hi, everyone. My name is Lizzie Salida. This is my first time at React Conf, and it's been an incredible experience so far. I have so many new ideas that I'm excited to take back home, and I'm sure you all feel the same way. I'm excited to share with you all about promoting transparency in government spending with React. So, what is transparency in government spending? Headlines like these may look familiar and have become more common in recent years, thanks in part to a piece of legislation called the Data Act and the website usaspending.gov. More recently in the news, students and employees have been calling into question their employers' contracts with the Immigration and Customs Enforcement Agency, or ICE. These conversations are possible because federal spending data is made available not only to government officials and auditors, but also to journalists, data analysts, and the American public. In fiscal year 2018, the government spent $4.11 trillion. So where did that money go? If you are a US citizen, how were your tax dollars spent? Thanks to usaspending.gov, you can find out. As a side note, fiscal year 2019 totals were announced earlier today, and spending went up to $4.4 trillion in 2019. So who am I, and why am I talking about this? I work remotely from Princeton, New Jersey, where I live with my husband, Michael, and our new kitten, Bobby. And I went to the College of William and Mary, where I studied computer science and also minored in art, so I love to paint and draw in my spare time. I work for Booz Allen Hamilton, which is a consulting firm headquartered just outside of Washington, D.C. I'm a lead technologist for them, which means that I'm primarily a software developer, but also a consultant. For the past 2.5 years, my client has been the United States Department of Treasury. I'm currently the front-end lead for usaspending.gov and a related application called the Data Act Broker. Today, I'd like to share with you some background information on the Data Act, a brief walkthrough of usaspending.gov, and some front-end patterns that we found helpful while developing this application. I'm also going to touch on the impact of this project on government IT projects in general. This mission of financial data transparency is almost as old as our country itself. Thomas Jefferson wanted our country's finances to be an open book, so that every man could comprehend them, investigate abuses, and to consequently control them. Only in recent years have we really had the tools and technologies, like React, to make this vision a reality. A rarity in today's political climate, data transparency has bipartisan support and has been expanded in the past 3 administrations. The Federal Funding, Accountability, and Transparency Act sparked the creation of the legacy usaspending.gov. The Digital Accountability and Transparency Act, or Data Act, required the establishment of government-wide standards for financial data and stipulated that new types of spending data be added to usaspending.gov, which prompted the project that I work on today. The Open Data Act in 2018 expanded federal data transparency efforts to other areas beyond just financial. Our solution is a collaboration between the Bureau of Fiscal Service, my company Booz Allen, another contractor Kearney & Company, and we've also had help from 18F, which is the digital arm of the General Services Administration. It is considered the first large-scale agile government-wide project. And our success has prompted other government projects to adopt the agile methodology. In the spirit of transparency, the code for our API and front-end applications are open source. We accept contributions and pull requests from the public, and we also have a service desk and our Jira boards that are open to the public. We chose React back in 2015 when it had been around for a few years but wasn't completely mainstream yet. We chose it because it was fast, and we knew we needed to render complex data visualizations, and also because it was component-based, and we knew we had repeatable elements we wanted to use throughout the site. Now let's take a look at how a user might interact with usaspending.gov. Let's say I'm inspired by last week's first all-female spacewalk and excited for Alex's talk about building a spaceship coming up after this. So I want to find out more about how much federal money is going into space exploration. From our homepage, I would go to the advanced search page. This is really the bread and butter of our application. And as you can see, there are many different filters that you can apply to the data. Because I'm interested in space exploration, I'll search for NASA as the awarding agency. When I apply this filter, we'll see a table of awards in the results with information about those awards, and it's also broken down by award type, for example, contracts, grants, or loans. I can also view my filters and how they've affected spending over time by comparing different years, quarters, or months. Can also view spending by geography to look at how the spending has been allocated to different states, congressional districts, or counties. Finally, you can view a breakdown of spending by category, and I might be interested in the recipients of these awards. You can click through to a recipient profile page. This one is a child recipient, so clicking on the parent brings me to this company's totals, and I can view how their transactions and the count of new awards has changed over time. There are profile pages for various entities on our site, including agencies and states and federal accounts, which we'll look at later. So I can search for NASA's agency profile page, which will show more information, like the fact that their budget makes up 0.3% of the US budgetary resources for 2019. I can also view a breakdown by different categories like object class, which are consistent across all agencies, for example, personnel compensation. I can also view their federal accounts, which is like a group of bank accounts that are allocated for a specific purpose. On the federal account profile, we can view spending so far, and again, view spending over time, and filter by different categories like those object classes. Another feature of our website is the Spending Explorer. And this allows us to explore federal spending from 3 different starting points. I'll choose budget function, which is like a large bucket or category for spending. For example, health or national defense. I can find one for space, science, and technology, and click through to see a breakdown by budget subfunction, which is a smaller category, and click through again. And then we'll be able to see all the federal accounts. And clicking on one of these will also generate a link back to that federal account profile page that we were looking at previously. These tree maps are a great example of why React was a good choice for our application. Each of the boxes is its own component, and we're using D3 to create the calculations and then rendering some custom SVG. Now that we've seen a little bit about how the site works, let's take a look at how it's built. Don't worry about understanding all of this, but the main idea is that we have a schema team that comes up with those government-wide standards for financial data. Those are then enforced by a series of validations in the Data Act Broker, which is the application that agencies log into to upload their spending data on a monthly or quarterly basis. We also ingest data from a variety of sources, for example, getting the latest zip codes from the US Postal Service. The data is kept in our data store, which powers a public-facing API, and usaspending.gov is the primary user of that API. Also leveraging the data is our sister site, the Data Lab. They do more complex data analytics to look at how federal spending affects specific issues, for example, homelessness or colleges and universities. Some front-end patterns that we've found helpful while adding to the site over the past almost 4 years include the container component pattern. So we'll have high-level containers where we connect to Redux, make API calls, and handle data parsing, and then pass that data down to simpler UI components. We're also using Redux. A good example of this is on that advanced search page. We're keeping the store for the staged filters in Redux so that that store can be accessed by both the individual filter containers as well as the submit button container, which uses the filter state to create an API request parameter. We also have directories for data mappings and helpers. Data mapping will convert values like a numeric code into a more human-readable name. And the helpers include our API calls and any sort of reusable logic that we need throughout the application. For example, a common one that we use converts dates to fiscal quarters. We also have API contracts that we use to coordinate with the backend team. This helps us to make sure that we're on the same page when we create a new endpoint or when we are making changes to an existing endpoint. These contracts can serve as a form of API documentation, which you can see here. They also can be run as a mock API if we need to start developing while the endpoint is still in progress. And we can also run tests against the live API to make sure that it's compliant. We went a little bit out of order, but here's our data mapping and helpers files. And finally, our data models are like the glue that connect raw data to our nicely formatted and digestible values for use in visualizations. I'm going to go a little bit more in depth with these because they're really at the core of our mission, taking complex data sets and helping the American public make sense of them. As I alluded to in the previous slides, most of our visualizations have a high-level container that makes an API call. That API response is then parsed using data model objects, which are then stored in Redux or local state and passed down as props. The UI components can then access consistently formatted properties of the object via prototypal inheritance. Our motivation for this pattern came when we noticed that we spent a lot of time trying to trace data points on a page back to their corresponding API fields. Sometimes a designer would come to us and want to change the format of a certain data point. Other times, the API developers would let us know that a field name or response structure was changing. And sometimes someone from service desk or a client would just ask, hey, where's this number coming from? We would have to step through many layers of the component hierarchy and notice that sometimes the same value was sometimes reformatted multiple times in multiple components, thanks to an anti-pattern that Becca called prop drilling yesterday. It was time-consuming and convoluted to get answers and make simple changes. We also noticed that there was a lot of formatting logic cluttering our UI components. As you can imagine on a financial site, we have to do a lot of formatting dollar amounts. And also because it's a government site, there are many entities with both a code and a description or abbreviation. But both of those fields are not always available or required, so we have to format the result based on what's available. This is a very simple example of one place we're using a data model. We're looking at the state profile page for Nevada, which shows the breakdown of spending by award type in the past 12 months. On the right side is the API response, which is a simple array of objects which each have an award type, a dollar amount, and a count of awards. On the left, you'll notice that we've converted that snake case award type into a more human-readable value, abbreviated the amounts with B for billion, M for million, and also added a comma to the counts to make large numbers easier to read. Looking at the data model file, we're creating an object called base award breakdown row and giving it a populate method which takes one of the objects from the API response as a parameter and then assigns properties to the object using the data. We're using Boolean logic to cast predictable falsy values if certain fields are unavailable. In some cases, we'll even cast to the string not available for optional fields. Below that, we're defining custom getters, which use our helper functions to format the dollar amount and number. From the container file, a base award breakdown row is created for each object in the array using object.create. The populate method is invoked, and the array of data model objects is stored in state to be passed down to the component via props. From the component, it's very clean and concise to access the data model's properties and custom getter methods. This pattern becomes even more useful for more complex objects and properties that can be shared among multiple models. For this, we have core models. In this case, core location formats addresses, congressional districts, etc. Location data is associated with multiple entities throughout our site. Here, we're using it to format recipient locations. The core model expects data to be in a specific format so that it can be reused even if API fields differ from endpoint to endpoint. So we format the data from the base model and then are adding core location to the prototype chain for base recipient's location property. From the component, we have access to core locations getters because they're in recipient.locations prototype chain. Data models can certainly be overkill in some scenarios, but for us, they've had the benefits of consistency, cleaner component code, and have streamlined making formatting and API changes, because when those types of data requests are made, we know to go right to the data model files. Finally, they've allowed us to reuse data logic by employing prototypal inheritance. Now I'd like to zoom out a little bit. I am a consultant after all, and not all government IT projects are considered a success. The first factor contributing to our success was a strong team. We need talented developers working on these problems for our country. Also, when things get hard, I can fall back on the fact that I'm contributing to this important mission of transparency. Working for the government is a little bit different because you're not motivated by profit and can really focus on making the best experience for your users. Because we're agile, we have a retrospective after each 2-week sprint and are always coming up with ideas to make our code reviews better, have smoother design handoffs, or even restructure our team. And it's been great that our processes have evolved along with the team. We also have a unique relationship with our clients. They're actually a part of our Slack workspace. They can see our pull request, GitHub notifications, can also see when we have to submit a hotfix because we created a bug. They're available to answer questions for us as we are for them, and that helps to build a culture of trust. Also important for the front-end team has been advocating for technical and developer experience improvements. This is not always easy with government clients because they often have pressure from their leadership or audits to ship new features and enhancements. So we've had to learn how to directly communicate the value of a healthy, forward-looking code base and the benefits of improved developer experience to stakeholders who may have a lot of domain knowledge but are not always technical themselves. In the past year, we've upgraded from React 15 to React 16. So we're not the quickest ones to the draw, but I consider it a success that it happened. We've also upgraded to Webpack 4, and that combination allowed us to show significant performance improvements to our clients, which then helps to reinforce that trust. We've also learned to be comfortable with making incremental improvements. For example, with each pull request, part of our code review checklist is to look for opportunities to add hooks, remove deprecated lifecycle methods, as we work on new features and enhancements. This project has also had an impact beyond just the site itself. First, as a success story for Agile in government. A similar financial reporting system took about 4 years to develop, and the MVP of the Data Act broker application was developed in about 6 months using Agile. This is because Agile allows for incremental progress. We're able to get more continuous feedback, perform user testing, which helps us to deliver value with every sprint. USAspending.gov also served as a predecessor for recreation.gov, another site that Booz Allen has been involved in, which uses Agile and a modern tech stack, including React and AWS GovCloud. If you're looking to plan your next trip to a national park, this is a great site to check out as well. Because we're open source, other projects have been able to use our components and code as a reference. I know from talking to colleagues at Booz Allen that, for example, the FDA was looking to leverage our glossary component, which is pretty neat. Finally, our data visualizations have been cited as examples as new projects have been starting up of the type of data visualization that they're looking for. As developers, we all stand on the shoulders of giants. So I'd like to thank the entire Data Act team, and specifically the past and current front-end teams. Mike and Kevin taught me much of what I know about React and helped to spearhead some of the patterns I shared with you today. Max and John have embraced our culture of continuous improvement and courageously advocated for technical improvements. If you're interested in finding out more about what the government is doing with open source, code.gov has a list of open source government projects, and they've also created the US Web Design System, which is a pretty complete design system. They even created their own font, which is really cool. And they also have great examples of common React components that are used on government websites. Finally, at USA Spending, we're not perfect and would love to see more pull requests and contributions from developers like you. Thank you.
Yes. Pretty good. Yeah? Yeah. We've reached the final stretch. It's home base. It's about to get really crazy in here. Really crazy. Actually, so behind the scenes, there is like a magical wonderland, a little universe of unicorns and elves that are making this whole conference happen constantly. One of them's right here, Megan. Oh, sorry, Amanda. I mean, like, we've been friends for 2 days. I'm exhausted. Her name's Amanda, and she's incredible. Everyone, Amanda? Okay. Sorry, I'm an idiot. Y'all know Jameson? He's sitting up there. There's Jameson. There's also Matt. Is Matt in the room? He's probably on a run. I feel like he's always on a run or working. Okay. There's Matt. Matt back there. Give it up for Matt. So Matt and Jameson put on this conference, and they do a really, really great job. We've also got everyone from, there's a company that they work with called Zero Slope. Y'all heard of it? Yeah, Zero Slope. So over here we have Tyler. Yeah? Tyler's incredible. Up front we have Sunny and Shiloh, and they've been doing like all of the chat moderating and just like all of the coordinating. So like before you get here, there's a group of people working tirelessly for days on end to make sure that you're happy. While you're here, they're like working days on end trying to make sure you're happy. And then after you're gone, having your night nap, they'll be here making sure that everything's cleaned up and coordinated. So like really like the biggest clap scream that you can possibly come up with right now, do it. For this time, yes, yes, yes. Because here's the deal, some conferences suck, and this one doesn't. And that's because of cool people like that. Okay, so here's Alex. I'm sorry if you heard me laugh backstage. I try to ask people questions before they come out, and I was like, what's your favorite candy? He's like, Milky Way. Get it? Because spaceships. And I made a laugh back there because too much candy. Anyway, it's a fun joke, and Milky Ways are delicious. Here's Alex.
Hi, everyone. It is so awesome to be here with you at React Conf, and I'm so excited to talk to you guys about my spaceship controls. You could say, who's in here has seen the Lego movie? Raise your hand high in the air. If they let us pick walk-on music, mine would be from the second Lego movie, where the evil, not evil person is like, Benny, do you love spaceships? Because I think they're great. And Benny the spaceman is like, spaceships? Loving spaceships is my one defining trait. Like, that's me. So, I'm Alex. You can find me on Twitter there. I tweet about spaceship and React and baking. And I want to take you on a journey for the next 5 minutes. You are the crew of one of these spaceships. Not like a rocket that goes up into the space to the International Space Station. No, you are traversing the stars, going to different systems, meeting with aliens, perhaps doing battle with angry aliens. You've got this, though, because you have a very talented, very trained crew. They may look like 5th and 6th graders, but trust me, they've got it where it counts. Your mission is fairly simple. You need to transport some weapons plans from a secret facility to the place where these weapons will be used to protect us from bad people that are trying to hurt us. And what could possibly go wrong, right? You get ambushed by those very angry aliens, and they call you up, and they say, I have angry words for you. This is what they say. Here it goes. Oh no, there it is.
Your last chance, Captain. Hand over the weapon plans and I will spare the lives of you and your crew.
Admiral Routh, are you aware that we are in Federation space? Any attack you make on us will be considered an act of war against the
The
Federation.
Federation has been at war with us ever since it formed. The weapon plans you carry are proof. Now hand over the plans or die.
Get weapons ready. I refuse.
They brought missiles onto our ship! Red alert! Red alert!
Impact in 3, 2...
Captain, our shields are down! Fire everything we got! Now, now, now!
Oh no! What happens next? For one thing, you're in big trouble. What should you do? Should you try and run? Well, you saw that you were completely surrounded. There's no way you could outrun all of those ships. You could try and fight, but again, there are a lot of them and only one of you. And then, one of your officers, the science officer, who is just in charge of little probes that are launched out into space to do sciencey things, you know? Not really meant for battle. But she speaks up and she's like, hang on, I wonder, I have some science probes, and these science probes can be equipped with hologram projector package. This uses hard light to project physical images into space. And they have this thing called the safety protocols, which keep them from actually hurting or damaging real physical objects. But what if we just project a whole bunch of good ships around us and deactivate the safety protocols and see what happens? And you, the captain, say, that's a crazy idea, but I think it'll work. Sorry, that is a very unusual idea, but I think it'll work. And so, you execute this plan, you launch the probe, you project the holograms, and huzzah, all of the enemy ships are destroyed. You make it safely to your destination. Congratulations, Captain and crew, you have successfully completed your mission! Now, the cool thing about this story that I just told you is it isn't science fiction. I mean, the things that happen in the story are, but the experiences that these crew members have is very real. It happens all the time at the space centers that I've been working with for the majority of my life. And what I want to talk to you today is Thorium, my Starship simulator controls that I built to facilitate these experiences. And I built these tools, this tool with React, GraphQL, and Apollo, mixing it all together to have this really dynamic, real-time experience for these crews of these simulators. The cool thing, though, is this has been around for a good long while. In fact, the first controls were developed in HyperCard. Who has used HyperCard before? Raise your hand. There are literally 6 hands in the air. There was a talk earlier today that mentioned HyperCard in passing. It was really cool. You could drag and drop controls onto the screen and give them scripts and stuff. If you've been following along the whole conference, you know exactly what I'm talking about with the previous talk. It was developed by this guy. His name is Victor Williamson, and back in the early 90s, he was a school teacher who wanted to give his students a great experience as they learned math and science and social studies. And so he had them use paper controls with a projector screen and transparencies for the main view screen. And he would sit underneath his desk pretending to be all of the aliens using his very dynamic voice. And it was really impressive. It was really cool what happened. They became engaged. They got interested. They wanted to do it more. And so he's taken this idea and tried to share it with as many people in as many ways as possible. And Thorium, my simulator controls, were developed for these space centers to help spread this mission of having a fun and interesting and engaging way of learning not only science, math, social studies, but also teamwork, leadership, and communication skills. This is the motto of the Space Center. Mortimer Adler was a philosopher focused on education, and he said that education is the freeing of the mind through the discipline of wonder. And that's kind of what I want to focus on today, is wonder-driven development. The idea that you can take this question, I wonder if, or I wonder how, and use it to drive whatever you decide to build. Your explorations, your side projects, your anything. I'm sure all of you have wondered something at some time, if it was possible, if it was affordable, if you could do it in the first place, and then just tried to figure it out. That's really the story of my experience with this project, building these simulator controls using web technologies. It really comes back to the crew. Remember, in my story, it was the science officer who wondered, can we do this using these tools that I have that don't seem like they might work, but maybe it will? And then they tried it, and it worked. Surprisingly, these students have this experience on a regular basis, being able to explore, to find these ways of solving problems that maybe nobody had ever thought of before. Before I dive in a little bit more, I want to talk a little bit about the space centers themselves, just so you have more context. The space centers are actually, the ones that Mr. Williamson, that school teacher, started, have all been based in Utah. So here we are in Las Vegas, Henderson area. Up there in Utah is where all of these space centers, these simulators are. And they've been running for the past over 20 years and have been expanding to additional locations in schools throughout the surrounding area so that lots of students can have the ability to use these controls and have these experiences. But the idea, the concept has actually spread across the United States and even to other parts of the world like Venezuela and Cambodia through other businesses and organizations trying to spread this idea. The crew, like I said before, is just a bunch of 5th and 6th graders for field trips. But anyone can be a crew on these spaceships. So if you think, oh, I want to do that, don't worry, you can. The age limit is 10, and it's a lower age limit, 10 and up. Awesome, absolutely. When the crew comes, they're each assigned a different position, like weapons officer or navigator, and of course you have to have a captain in charge of telling everyone what the best idea is and pretending like you know what the best idea is. The staff at the space centers make sure that they know how to do their jobs properly. They give them a mission like transport these weapons plans, or explore this area of space, or negotiate with these aliens. And then they go and do it. Now, there is a flight director. Oh, excuse me. Here's an older crew that came. I pulled this off of one of the Space Center's Facebook pages. They came for their business, just to do a fun little activity with their team. And it looks like they won with happy smiles on their faces. The flight director is one of the staff members. They are in charge of running everything behind the scenes. They play all of the acting parts using a voice changer and microphone. They coordinate everything that's being shown on the main view screen. They lead and guide the crew as they go through this experience together. And everything that they do happens in the control room. So this is a picture of me inside the control room. As you can see, there's a lot of stuff going on, so let me annotate it for you. We've got the microphone, which the flight director uses to talk to the crew. We've got the soundboard for controlling all of the various sound inputs, like the music computer. You gotta have mood music so that the crew knows what they're supposed to be feeling at any given moment. Very cinematic. The voice changer, because you can only do this for so long. You gotta have something to make it so it doesn't sound like your voice. A typing keyboard so you can type through to the computer controls on the crew stations, but also a sound keyboard where each key plays a different sound effect. The DVD and video remote so that you can play different things on the main view screen using DVDs. The computer, which controls what's on the crew's screens, allows the flight director to manipulate that universe. The camera, so you can see what's going on the bridge, and the sound of the microphones coming from the bridge, you can get that feed. And then finally, the light dimmer knob, so that you can switch from blue lights to red lights if they go to red alert, and then if they get attacked and their ship starts exploding, you can just shake the knob back and forth, and that simulates an explosion. As I was working and building these controls, I realized there's a lot of stuff that can be improved here. Being able to make it so the sound keyboard does more than just play sounds, or make it so that you can control the lights using computers so that it automatically shakes the lights for you, as fun as it is to shake a light dimmer back and forth. You use what tools you have available, I guess. So that brings us to the ship controls. Like I said, it's called Thorium, and I started working on it about 3 or 4 years ago. I specifically did it because I wanted to learn React and GraphQL and Apollo. This was right when Apollo subscriptions, or GraphQL subscriptions, were built into Apollo so that you could have real-time data being transferred between computers, which is perfect for a real-time game like this. And so I started building it. As I was building it, I wondered if I could actually accomplish the task that I had at hand, because typically you don't use web technologies to build Starship Simulator controls. There were a lot of things that I wondered along the way, and that's what I want to demonstrate for you now, is the different things that I wondered and how I found solutions for those things. So, first thing is having dynamic crew stations. Like I mentioned before, there are a whole bunch of different simulators in different locations. Some of them take up to 12 crew members. Some of them only take 6 crew members. And that means that different computer controls need to be distributed to different computer stations. Since I wanted everything to be able to run in a web browser, I needed to find a way to send the information about what screen should have what stations to those computers, and then have them display the correct screen. Fortunately, with GraphQL and React, and the fact that in React everything's a component, it's really easy to just tell them what components they need to show and then have them show it. So let me show you that really quick. Here, this is for the flight director. They can see the different computers that are connected to the Thorium server, and they can choose which station, which screen they want to show. So we have a bridge client here that's one of the cruise stations, and it's just this tab here. It just shows these wonderful credits of people that have helped with the project. But as soon as I come change a station, like if we wanted to show the communication station, for example, it would change, and we would see that station show up with the frame and everything else. And I can log in, say that I'm Alex, and it takes me to this short-range communication screen where I can choose who I want to communicate with. But if I wanted to change the station to be something else, all I have to do is come over here, change it to, for example, sensors, and then I can see my sensor grid with all of the different things outside of my ship here on this radar screen. In fact, if I wanted to, I could demonstrate what we did earlier with launching the science probe and putting the hologram projector package on it. So I can come over here to probe construction, switch to this screen, find my science probe, grab a, where is it? Hologram projector package, add that to my probe, and then I can launch it by giving it a name. And then the probe launches off into space. The flight director gets to decide what happens with that probe. So if the crew were to perhaps talk to the main computer of their ship, which is actually the flight director, but don't tell them, the main computer could then deactivate the safety protocols and project all of the images of the ships around the ships, the bad guys. The way that I'm doing this is really easy with React, because it literally is the way that React works. First, I need to find out what screens are available on the specific station. Every single station, every single computer that's connected to the Thorium server is given or assigned a unique client ID that the server uses to know which client is which. When the client connects, it subscribes to this client change subscription. This is a GraphQL subscription. It gives it the client ID, which the client has, and it requests the information that it needs to display the frame that you saw. So the simulator and the name of the simulator that they're on. In this case, it was the USS Voyager. And the name of the station, the communication station or the sensor station. And then finally, all of the cards or screens which that station has. This returns a list with the name of the screen and then the name of the React component which it needs to render. At this point, all I have to do is just find that React component and render it. And that's what this little component here does. It imports all of the cards or the screens from a folder that has all of them. It gets the component name from props, it grabs it out of the list of cards, and displays it as a component, passing in all of the necessary props that it needs to get its data using GraphQL. Each of the individual cards has its own GraphQL queries as part of it, and so as soon as it loads, it grabs the data and then displays what it needs to on the screen. There's another situation, though, another side of things that needs to be managed, and that's the flight director's controls. I wanted to make it so that the flight director had as much flexibility as the crew. This is what previous versions of the simulator controls looked like. It's a little bit of a mess. Kind of difficult to understand everything that's going on there. It's kind of like the Bloomberg terminal. People use it as an example of something that has terrible UX for the uninitiated, but if you know how to use it, then it's really great, and you know exactly what you need at a moment's glance. I wanted to make this better, though. I wanted to make it so that new flight directors had the tools that they needed to get up and running quickly and easily without having to learn where everything was. I don't think that I've solved that yet. This is something that is an ongoing iterative process that I'm trying to improve as time goes on. So we'll see where that goes. But for right now, I think I've made a couple of breakthroughs. That specifically is the dynamic control grid, which I want to show you now. Once the flight director has assigned all of the stations to the different clients that are connected, they can go to the core screen, which shows them everything. It's their control screen for everything going on in the simulation. It looks like this. You can see that I can control the sensor contacts here. It's just a mini sensor grid. I've got something here that I can use to do actions on the different stations or change the alert condition to red alert, for example. Down here, I have what's called the core feed, which takes events that happen as part of the simulation and puts the actionable events in this list. And so I can see that there was a probe launched with the hologram projector package on it, or rather it was named hologram. And then if I want to, through the beauty of React, I can click on this and it can grab the necessary control component for that action and display it for me right here. So I can click on this probe and see if they loaded the hologram projector package onto it correctly. And then if I wanted to, I could destroy the probe if the bad guys got wise and realized what they were doing. Oh, yes, goodbye hologram probe. And then, in the middle, I have the dynamic core grid, which allows me to choose any of the different core functionality controls to do what needs to happen during the flight. So for example, on the command screen that the captain and first officer use, they can see a list of mission objectives. And if I want to change that or view those objectives, all I have to do is just grab the objectives core, add a new objective, and say, deliver the weapons plans. And then it will appear in the captain's list, and I can see it there. Obviously, this isn't perfect because I have to know what functionality is available. But in order to make it just a little bit easier to discover that functionality, I made it so that you can press and hold the function keys to show several core components together, and they're grouped by the type of station that they're useful for. So in this case, I have all of the navigation components that I might need for navigating the ship. Finally, I made it so that this dynamic layout, you can create and save layouts for specific situations that the crew might find themselves in. So if we were to get into battle, for example, I can come and choose the battle layout, and it will pull up all of the information that I need for when the crew is in battle. The phasers, which are their energy weapons, their projectile torpedoes, their shields, and a whole bunch of other stuff. Their thrusters for when they need to dodge. And that makes it easy for me to only have the information that I need for the specific setting. The next thing that I wondered if I could improve upon was the mission timeline. And to do that, I created a thing. I don't know if anyone's ever done this before, and apologies in advance to Lee and everyone who made GraphQL possible. But I did something weird with GraphQL, and I want to tell you about it. First, let me show you what I wanted to do. Over here on the other side of my screen, I have what I call the mission timeline. These missions follow usually a set of storyline points, things that happen at different points during the mission, and it's usually pretty linear. And so I can have specific actions that happen as part of this storyline, and all I have to do is just click the button to go to the next step. And then it can give me information about what I need to do as the flight director as well. So here I can see that I've got an action that sets up all of my sensor contacts that I need for the mission and sets up scan answers for when the crew is requesting information from the main computer. So I click this action to execute it, and it puts all of the sensor contacts here. They don't have images, though. That's a bummer. Oh well, you can see that they're there. On top of that, and then it goes to the next step, and I can continue moving on through all of these steps. The cool thing about each of these steps is they are actually GraphQL mutations that have been exposed to the flight director as being available for them to use in this timeline setup. So they're able to see all of the different mutations that they can choose to use, pick the ones that they want, add the arguments using a UI. So let me show you that, actually. I'll grab the core here, and then if I wanted to do that same thing with objectives, I can click this Add Objective action, and I will also pull up the objectives core so that you can see what happens. And the objective title, this is a GraphQL argument that I'm going to type in here. It's just to don't die. That would be bad. You'd probably fail your mission if you died. And then I click the trigger macro button. It executes that mutation and uses the arguments that I provided and puts it into this list of objectives. This is something the users that are using these controls have no idea what GraphQL mutations are, but they do know that they want to perform certain actions at certain times, and so I made it possible for them to see what actions were available and make it so that they could configure that. The way that I did that was using an introspection query. So this is what my schema definition is for some of the mutations. In this case, one that changes the simulator layout, or the way that the chrome around the controls looks, and then another for changing the alert level. And I have the different arguments that I can pass in, and I also have GraphQL comments around them that specify that these are mutation actions that can be consumed by them as they're configuring things. On the client side, I'm doing an introspection query, querying the schema directly to get the different mutations that the schema provides. This is a feature that Apollo Server and a lot of other GraphQL servers provide that you can enable or disable however you want. It's typically just used for development, but I have it on in production so that this feature can work, so that it can query and see what mutations are available. And then it just grabs the description off of the different fields and uses that to know what mutations are actions and which aren't. So that's what's generating this list here. All of these are mutations that have that description on it. It makes it really easy for them to be able to create all kinds of different things, saying what actions they want to happen arbitrarily based on whatever they want. I don't know what that's going to be. They get to choose. The next thing is the main view screen. This is the monitor, the TV that is at the very front of the ship that shows what's going on outside. And like I said before, typically that's just a DVD that's playing whatever, and sometimes they hit the pause button and it looks really weird because when you pause DVDs, it looks weird sometimes. I wanted to make it so that we had a more dynamic view screen that showed things based on what the crew was doing. This isn't like Unity level 3D universe, although with WebGL that certainly is possible, and I'm totally want to do that someday. But right now, it just responds based on the crew's input, what happens in the simulation. So as a quick demo, here's what the view screen looks like right now. It's just the rotating ship logo. I can come over here and execute a couple more timeline steps, and then there's a timeline step for changing what's showing on the view screen. In this case, it shows the ship undocking from their mothership. So if you click this, you can see that ship, the docking bay door opening, and then it lifts off and then flies off into space. And that's something that might be necessary to show them for a specific point in their mission. However, there are some things that happen all the time, like when they activate their engines. We want to make it so that when they activate their engines, it automatically shows the stars flying by as they're going at warp speed, faster than the speed of light. And so I created an option that makes the view screen automatic based on what the crew is doing. So I click this button, and now it just shows that we're at red alert. Maybe we shouldn't be at red alert anymore. And now we just see this lovely scan pass image, since nothing really is going on. But if the crew were to activate their engines to, say, warp factor 8, then we would see stars, And slowly, as the ship accelerates, you can barely hear the sound effect, I'm sorry. They accelerate to warp speed, and now you can see the stars as they fly by. And this is 100% based on the speed that they're going, so as I change the speed, it just sends a GraphQL subscription to the component that's rendering these stars and slows them down or speeds them up as necessary. The last thing that I want to talk about is subscription-based animation. This is actually kind of crazy. I wanted to make it so that you could move things on a screen in the same way on two separate computers. In order to do that, you have to do animation on the server and send the movements to different computers using WebSockets in this case. And I'm using GraphQL subscriptions for this. I wondered if that was even possible. Like, can this be done in a way that is actually performant? And I don't know, maybe it can be done. I implemented this using a feature called the CRM. It's Remote Fighters. And if I activate the CRM core, I can activate my stations. Actually, I need to change the view screen to be a second station. And if I activate all of the stations, then we can see it shows this fighter control, and we can see information about the fighter, its shield integrity and stuff. And if I click Launch Fighter, then I get, one moment, please. Then I get this little contact that I can fly around. Oh, come on. Then I get this little contact that I can fly around in space. And as you can see, that's pretty smooth movement there. Even if I were to add several more contacts, like some enemy fighters, you can barely see it here in this little mini-map down here, those little red dots. And I can move around, click on one, load a torpedo, and fire my torpedo at it, and darn, it missed. That's a bummer. But I can launch another fighter, and maybe this one will have more luck. I can fly after my friend. There he is. And we can fly around together and take out these bad guys. All of this is happening on the server, and it's sending this to the clients. Now, the way that it's doing it, I can't send it at 60 frames a second, which is what smooth animation needs, because that's just way too much network traffic. And the GraphQL client normalizer and caching mechanisms can't handle that. It's CPU bound. It's just too much. And so what I did is I send it at 50 milliseconds, every 50 milliseconds, which is 20 frames a second. It can handle that speed on all of the hardware that the space centers are using. And then I need to interpolate the different states of the animation. So I need to put animation values in between all of the different animations that I get from the server. The problem with that is it's kind of complicated. The linear interpolation function, which I'm using, is pretty simple, but keeping that state in React is kind of hard. But I thought, well, hooks just came out. This is a perfect case for hooks. And so I wrote a hook called useInterpolate. It has a use state. It has use previous, which gets the previous value. It has a use animation frame, which calculates all of those animation frames in between and animates it, stores it all in React state. And it didn't, well, it worked. It wasn't very performant. I'm sorry. But I couldn't ship it. It just wasn't good enough. And then I thought, I wonder if there's a better way. I wonder if there's a tool that browsers provide that could make this actually work. Would you believe it? CSS transition is basically a linear interpolation. So I got rid of that hook. It was beautiful. It was really gnarly, but I replaced it with 3 lines of CSS, and now it's exactly what you see. Lesson learned, you don't have to do it the most complicated way. There were a couple more things that I was trying to figure out, some of them I did figure out, like being able to track multiple open web browser tabs and have them communicate with each other. You've actually seen that as I've had multiple clients open at the same time. Having React component plugins that are able to be loaded in from a remote location with React Lazy, I didn't actually figure that out. The build tooling is complicated, but I think it's possible. I know that Sophie talked about creating a React DOM renderer. I actually created a React renderer for computer-controlled lighting so that you could use React components for all of your lights and have them render out to DMX, that's the computer-controlled lighting protocol, it becomes DMX signals. And then being able to do multi-channel web audio so that you can play sound effects in different channels of your surround sound system. It's been a really fun project, and I've wondered a lot of things and discovered a lot of things that work and a lot of things that don't. This isn't just limited to me, though. Before I go on, I want to mention that Thorium is open source, so if you want to check it out, it's on GitHub. I'll post in the Slack or on Twitter. I want to give a shout out to all of these wonderful people, and apologies to the last two for going off there. CSS is hard. But as I was watching all of the talks, I was writing down all of the things that I'm sure these people wondered as they went about their daily lives and prepared these talks. And it's really cool to see the results of what they wondered. I feel like we've all been incredibly educated and informed about so many incredible things. I learned a lot during this conference. There's so much out there, and I'm sure that every single ReactConf after this one will have more incredible things that people have wondered that eventually we discover and find out what's actually possible. I want to call out one other example that I think is really cool, and that's TinkerSynth by Josh Como. Sorry for cutting off there. Who's used TinkerSynth? Raise your hand high in the air. Wow. Everybody, you should go and DuckDuckGo TinkerSynth, because it is an incredible project that Josh put a lot of time and effort into as he himself was wondering what was possible. It allows you to generate your own cool graphics using tools and controls that he created. And following the process of him creating this on Twitter was absolutely astounding. Not only that, but he's given you something that you can use to wonder, how is this all going to work and fit together? I want to close with this great quote from another great in our industry, Henry Zhu. He wrote a blog post called Seeking Serendipity, and I feel like this really resonates with my message today. Describing serendipity, but I think also perhaps wonder, it's something that is both unexpected and fortunate. It's what I didn't even know I was looking for, but it goes beyond my imagination. We can't force it. It happens to us and makes us feel alive. I can tell you that this project I've been working on has made me feel alive. It has given me so many great opportunities and so many great things to wonder. And I would invite you to think to yourself, what things can you wonder? And then just try to make it happen. Thank you very much.
Good job. Y'all see this? Y'all see this graphic? That's our graphic. That's our graphic. Okay, guess what? That was it. That was the last talk. Y'all feel good about it? Okay. Me and the folks from Zero Slope are about to start a riot. We're going to throw t-shirts in the crowd. Y'all ready to like knock over some chairs? Yeah. Okay, here we go. Ready? Y'all coming? We're going to throw them. Ugh, I'm not good at throwing things. This is my insuperior arm. Ugh. 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 I told you, I'm not good at throwing things. Oh, everyone's like, oh, it's a shirt I already got. Well, I already have this shirt. Congratulations on your second shirt. Give it to your significant other or your cat. Okay, we're all done, and that was incredible. Thank you guys so much for coming. Thank you to all these speakers that have prepared really incredible talks and amazing content. They put so much heart and soul into those. Yeah. I'm proud of each and every one of them, the first-time speakers. This was really interesting, and most important, thanks to all of you raffle winners. Thanks for coming to the conference. Thanks for staying here the whole time. Let's take a pic together. Let's have fun. Follow me on Twitter. I'll make you laugh. Thanks. Come on up. Everyone up here.